Namaskar, I welcome all of you to the second day of two-day webinar on publication ethics, and I'm going to talk about predatory journals and conferences and what we should be knowing as a researcher or as a supervisor, what we should be cautious about. So, predatory journals and conferences, issues and challenges. No, viewers, it's very important for us to know why do we undertake research? We undertake research because of various reasons.
Tell me, madam.
I'm audible, no?
Yes. Yeah, audible, madam, audible.
Because research, it's our bread and butter, of course. This is the basic reason. Then we undertake research because we identify some problem and which does need to be addressed. So we undertake to find out solutions to the existing problems. Then once we find out some solution to some existing problem, then what is most important is that we need to communicate the research findings. Because as you would agree that research is all about communication. If you undertake research, you want others to know about your findings, because until or unless your findings are made available to the wider audience, to the global audience, it doesn't have any relevance. You want right, and what is important is you want right audience, you want global readership. You just don't undertake research just, जमा करने के लिए नहीं करते हैं research की, जमा कर दी और वो library में जमा हो गई. We want people to know about our research. We want people to read our research. We want others to browse our research. We want right audience. We want more and more readers. We want global readership. We want citations. We want others to build on our work. And our research findings and our research becomes foundation for future research. This is very important. So in order to disseminate our research findings, what do? We publish articles, we publish our research findings as articles, we publish them as conference papers, we publish them as book chapters, we may develop books out of our thesis. But by and large, scholarly journals are considered as the most common channels, as the most common media for communicating research findings. And importance as a researcher, you should know, I repeat, you should understand what does a journal do? What does a journal article do for you? Basically, it has four functions. First is that of registration, because it registers your claim. When you get published, you register your claim that you are the first one to report what you are reporting about. This is the first function. And the second function is that of certification. That means whenever you publish, your manuscript undergoes peer review. It is evaluated, it is scrutinized for the right methodology in order to ensure that you have followed the right methodology. The findings which you have reported are in sync with the methodology which you have adopted. That means the peer review procedure, the journal certifies that whatever you have published is final, is ultimate, is definitive, is fit enough to be cited by others. That means your work is fit enough to serve as a foundation for future research. Then third function is that of dissemination. That means you want to spread your research findings. You want to communicate your research findings. You want maximum users, maximum readers for your findings. And this is what a journal article does. It disseminates, it spreads your research findings. Then archiving, that means whenever your article is published, whenever your manuscript is published as a journal article, it becomes a record forever. It becomes a permanent record for future generation of researchers to browse, to use, and build their work. So these are four important functions of a journal or a journal article. And then as a researcher, you must know that performance of researchers and faculty members is judged by the number of publications as well as where they get published. So remember, I underline where they get published. That means various outlets or various journals where you publish are equally important. And another which important thing is that getting published in internationally indexed journals, there is a privilege and recognition associated with it. And that is why this is the reason, or you may say, this is one of the reasons which motivates researchers to publish in English so that they get maximum audience, so that they get global audience. But the problem is, in the initial stage of research, in their initial stage of research, researchers do not know about the appropriate publishing outlets because they are ignorant or they are clueless where to publish. So if you are in your initial stage of research, I want to drive home that there are various sources which help you in identifying the right journal, the right outlet for your research findings. The first one is you must know about this University Grants Commission Consortium for Academic and Research Ethics, UGC. If you are completely clueless, you do not know where to publish, this is a very good, perfect starting point for you. It lists all the journals which are reputed, which are accepted in their fields. So the slide shows that, and it message over here for you is, if because you cannot just log in and see the list of all well accepted, all indexed journals of your field. You have to register with the website for the first time and use your username and password credentials to log into it to access the list of journals. So this is very important, and this should be the starting point, and you should be in the know of this UGC care. And my advice to everyone, to all the viewers, to register with the website if you have not. Second one, this shows, in the coming slides, I'll be shedding light on predatory journals. So you must see this, that this website also lists cloned journals. Cloned journals are the ones, that means they are fake journals, but they try to copy the legitimate or authoritative or the original journals. So list of cloned journals is very important for you to know about this list. So you can see the original journal is on the left hand side and the cloned journal is. So this website, this list will give you an idea of how the predators or the fake journals try to deceive the researchers by naming their journals very closely to the original ones. On the left side, you can see the original journal, and on the right side, you can see how the publisher has tried to pick up the real name in order to deceive the researchers. Another important journal is if you are in the initial stage of your research, if you have prepared a manuscript, but you are totally clueless, you are totally at loss where to submit your manuscript, then this manuscript matcher of Web of Science, it helps you in finding out the right journal for your research. And most of the libraries provide access to EndNote Basic or to this feature through Web of Science. So the only thing you are required to do, you must register with the this EndNote Basic in order to access this feature. Once you register, you will get username and password, and you can use these credentials to find out the right journal for your research findings. Here simply you have to key in your title, cut and paste your abstract, and it will show you different journals where you can submit your manuscript. Then another Open Journal Matcher. This is another website where it helps you in finding the right journal. You simply enter your abstract over here and it will search the potential journals. Enter your abstract here and it will list the journals. For example, it will list the journals that you can see on the screen. Various journals are listed with their ISSN number. And then another website which helps you in finding out the right journals is Journal Finder. This, as you can see on the screen, this Journal Finder is being provided by Elsevier. That means you will be able to find the right journals, but this is publisher specific. You will be finding journals published by Elsevier only. That means you have to simply key in your abstract, keywords, field of research, and then it gives you everything. Publication type, that means whether you want to publish in open access or journal with subscription. It will show you the journal impact of the journal. It will show you review and publication time. That means this is very important for researchers to know that what is the turnaround, what is the time lag, what is the time, what time does it take, between the submission and the final publication, because this is very important for researchers to know. So if you use this Journal Finder, all this information you will get. Then another website which helps you in finding is JAN, that is Journal Author Name Estimator. And these websites help you in, in keeping away, from predatory journals. We will be talking about that. Then all researchers must know about this directory of open access journals. That means if they have some doubt and if they want to publish in some open access, and if they have some doubt whether it is an authoritative one or it is a fake one, not a genuine one, then they can just simply go to this website, DOAJ, Directory of Open Access Journals, and they can simply key in and find out whether the journal is an authentic one or not. So I'm showing these sources because it's, as a researcher, it's very important for you to know about these. Then only you will be able to demarcate, you will be able to differentiate the original ones from the fake ones. And why do we need to know about these resources, about these websites, about these facilities? Because these websites, these resources, these facilities help us in, in identifying the genuine resource, in demarcating the genuine and the predatory journals. Because predatory journals, they exist and they thrive on the ignorance, they encash on the ignorance of the researchers. Your ignorance becomes their strength. Your weakness becomes their strength. So please remember that you need to know about different sources in order to, in order to publish your findings in right publishing, in right journals, in right outlets. For example, you see, this is an International Journal of Current Research, and it shows, you can see on the right-hand side, invited for research article, fast publication, impact factor journal. And if you, generally these predatory journals, they send information through emails to new researchers, to new authors. So generally they send it through emails, and they provide all these information. fast publication, because they know it that researchers, as new researchers, they are supposed to have publications. So if they promote, if they commit that manuscript will be published in less time, that naturally new researchers will be drawn towards these journals. So this is International Journal of Current Research, or for that matter, if you get any, and if you can see the impact factor is 7.749. So this message over here is that if you get any kind of mail from any journal soliciting your submission, then you may cross-check what are the sites. As I told you, simply you can register with website of UGC Carelist, and just once you log in, and you can just key in this International Journal of Current Research. This is the mail I received from the journal. I think I received it a couple of days ago. And no real journal offered this kind of thing. Certificate of indexing. This certificate is awarded to International Journal of Current Research. It doesn't happen. It doesn't happen in established, well-established, reputed journals of any field. So then what happened? This is the mail I received from International Journal of Current Research. And then when I thought there was something suspicious about it, then I logged into UGC Carelist and I just keyed in. I keyed in its ISSN number, and UGC Carelist displayed that this journal is not there. Then I keyed in its title, then it was again no any journal, it's not there. Then this is another mail which I received, International Journal of Arts and Social Sciences, which you can see on the screen. It says it's an international journal which aims at meeting all the needs of diverse sections of people in the areas of humanities and social studies. And what I want to drive home is that in all these journals, which are not established or genuine ones or fake ones, their turnaround time is very less. As you can see on the screen, it says, we request you to submit your papers on or before August 20. Paper submission date deadline, they specify 20th August. Acceptance or rejection notification, it says 5 to 6 days. Paper online publication 30th August 2020. But in real journals or in the established journals, it doesn't happen. You can see turnaround time is so less. They advertise, they ask you to submit by 20th August, and they commit to publish by 30th August. So this is how you can make out. Quick turnaround is time interval from time of submission to the time of publication. Usually in well-established journal, it takes 12 to 18 months to get published. That means it takes time lag when you submit when you upload it on the submission portal and you get published, it is 12 to 18 months. So in this, in the previous slide, you could see that turnaround was just 10 days. So these things you should be careful of when you are selecting any journal for your submission. No, then the previous slide shows some of the websites, some of the facilities which you can access to find out the right journal for your work. Because why do you need to find out the right journal? Because you need to know about the right journals, because there are some wrong journals at the same time which exist. So, and these wrong journals are also known as predatory journals. Predator, what does it mean? Predator is, as per Cambridge Dictionary, it is animal which hurts, which kills and eats other animals. And predator is also used for someone who follows others in order to harm them or in order to commit a crime against them. So predatory journals, they prey, they try to harm, they use the innocence of new researchers in order to harm them. Predatory journal, this was a term coined by Jeffrey Beall, who was basically a librarian. And these predatory journals, they are also known as pseudo journals, and they exploit the model of open access publishing. What happens in open access publishing? Open access journals, they publish, they don't charge any money for you. But there are certain subscription journals, like well-established journals like Elsevier, like Sage, like Wiley, and so on and so forth. They charge author processing fees in order to make your findings, in order to make your articles available in open access immediately upon publication. That means once it is published, it is made available in open access. For that, they charge APC, which is author processing fees. But then remember, all these journals like Elsevier, Sage, they stick to peer reviewing procedure. Once the manuscript undergoes peer review process, it is accepted, then only it is communicated to the researchers for APC. And let me tell you, when you submit any journal, for example, say Emerald, then once you get published, then you are asked whether you would like to make your article available in public domain immediately upon publication. Once you say yes, then you'll have to pay for it. Once you say no, then you need not pay for it and it will get published. So this model, where the journals like publishers like established one like Elsevier and Sage, etc., they publish your article in open access. They make it available in open access up after payment, and this is known as gold open access. And what happens in predatory journals, they try to imitate this model, they try to misuse this model of gold open access and extract money, mint money from authors. So some of the features, characteristic features of predatory journals, they charge publishing fees, APC, and all the journals which I talked of, for example, all the leading publishers, they provide the information very clearly on the website that what will be the author processing fees for the authors. And then their model, the model of predatory journals, is not clear. How will be they charging? And their websites, and this slide shows some of the characteristics of predatory journals. Their websites resemble the websites of original all legitimate websites. Names very similar to deceive the researchers. As I showed you a slide of cloned journals list which is being provided by Ugcc here. They do not have submission portal. For example, you must be in the process of submitting manuscript, and you must have observed that all these genuine, authenticate journals, they don't invite you to submit through emails. They have a submission portal where you are supposed to create an account, where you are supposed to register and create an account, and then you can use your credentials to log into the submission portal and upload your manuscript. But these predatory journals do not have this facility of submission portal, and they do not undertake peer review procedure. You know, peer review is very important because when you submit a manuscript, it is evaluated on different parameters for the content which you have published, for the methodology which you have used, for the findings which you have reported. But all these things are not taken care of by predatory journals. And I showed you in one of the slides that turnaround time is very less in predatory journals. They do not follow standards of the field. They do not have submission portal. And another thing which you must take care of is that all these journals claim to have impact factor. As I showed you one of the journals which was not there in UGC care list, it says on its website that it is a impact factor of more than 7 point something. Then you must remember that no journal can claim to have impact factor. Journals must be vetted. If any journal is claiming to have claims that it has an impact factor, then it must be there in journal citation report, because only journal citation report provides impact factor to the journals. Then these predatory journals, they claim to be indexed in international bibliographic and citation databases. They use images and logos on their website, images and logos of well-established journals in order to deceive the researchers. They don't have any editorial board, and contact address on the websites is not very clearly mentioned. And it's very important for you to know, at times they may have editorial board, and in the editorial board, they will use the names of well-established researchers of the field without taking their permission. That the well-established figures or the scientists or researchers, they are not aware that their names are being misused. So you should be clear of these things. You should be at least in the know of these things. When you are checking for a journal, you can check along these parameters. Contact address is also not clear. Then you see sometimes real journals know that there are fake sites which exist in parallel, and they try to misguide and the new researchers. So Current Science is a real journal, and it has put a notice on its website which says, we have given alert notice about the fake journals since July 2017, and we have been receiving messages even now from people who have fallen prey to fake journals that are imitating our current science. These victims have been defrauded into paying money to have their article published and in what they believe to be the true current science journal. The alert notice is to warn researchers and authors about this serious problem. I showed you in the list of clone journals that how they try to imitate the original journal. They try to imitate the website of original journal. So this Current Science is an original journal, and since the editor has put this notice, because he came to know that there are certain players in the market who are imitating the website of the real journal in order to deceive the researchers. So the message which I want to drive home is that you should be aware of all these factors. You can check all these things on the websites of the journals in order to distinguish the real ones from the fake ones. Then, like predatory journals, we also have predatory conferences. And as you will agree, everybody will agree that, conferences have tremendous importance, because we attend conferences in order to network with other researchers, in order to collaborate with them. Maybe we find some researcher who's working in the same area as we are working in, and we may like to collaborate. And as you know, interaction is the essence of professional development. We are no Robinson Crusoes. We are no islands. We depend on one another. We collaborate with one another, because we collaborate because one may be expert in writing, another may be expert in analyzing, in interpreting the result. The third person may be an expert in using, in making the best use of statistical tools and tests. So we collaborate in order to pool in the expertise of different authors, different researchers. We may want to interact, we may want to follow best practices, we may want to know what best practices other researchers are following. We may want to pool in resources, we may want to pool in infrastructure. That's why we collaborate. And that is why we attend conferences. And at times, it also happens that as young researchers, when we attend some conference, we get to listen to the stalwarts of the field as keynote speakers. So these are some of the main reasons we attend conferences. But then you have to decide. There are some good conferences, some genuine ones, but then there are bogus, fake, vanity conferences too. That is why you need to be cautious in, whenever you are planning to attend a conference. You must ensure that it's an authentic one and it's an original one. Predatory publishers or specialized conference groups organize them. These predatory conferences are being organized by predatory publishers, and their goal is profit making, and they have no interest, they are not at all into advancing the frontiers of science and knowledge. And what happens, these the organizers of these predatory conferences, they use web crawlers to locate information about authors who may be potential attendees. And how do they use web crawlers? They use web crawlers on the journal's website in order to extract, once you get published, in any journal, and then you will find that you are getting emails from these predatory conferences, from the organizers of these predatory conferences. And organizers send information through free email accounts. They charge you for attendance, for abstract presentation, and commit to publishing. They commit that they will publish your papers which you present in peer-reviewed journals. And they claim that they have existed in the field for long, and they and name their conferences or meetings as international, global, or world conferences. But then you must ensure that you get any information or you receive any email from any international or any conference which says international symposium or world conference, but then you should not be lured into it. You should check before attending or before registering for it. And what about these further downsides of these are that these at times these conferences can be cancelled with no provision for refunding. That means they will charge registration fees, and any moment the conference can be cancelled, but the attendees or the authors will not be refunded their registration fees. The first time authors who are corresponding authors to get unsolicited emails from predatory journals and fraudulent conference organizers to submit manuscripts to journals and participate in the conferences. And these predatory journals and conferences, they exist. They are not, it's not that they are specific to certain fields, they are specific to certain subjects. They are prevalent in all subjects. And the reason why do and even it has been observed, many studies, many surveys have revealed, have highlighted that even the researchers from well-established institutes like IITs and ITs, they also publish in these predatory journals, and they also attend these predatory conferences. So what are the various reasons? Why do the researchers do that? Why do they want to get published in predatory journals? And why do they want to attend predatory conferences? First you will agree that there is fierce competition. Everybody wants to, everybody wants to dress up their CVs. Sometimes we are carried away. Sometimes, we succumb to the lure of writing in our CVs that I delivered a keynote address at World Conference of so and so. We are tempted to write in our CVs. We are tempted to dress up our CVs as chaired a technical session in World Symposium. So these are the things, and you will agree that all promotions, evaluations, and recruitments, they are all associated, they are all linked to number of papers which you publish, the number of papers which you present in conferences. And at times it also happens that early career researchers, they are completely clueless, they are completely ignorant, they do not know what is the distinction, how to differentiate a real conference or a real journal or a genuine run journal from the bogus one. And then cognizant researchers, why do there are researchers, they do it in spite of knowing that journal is not the right journal, for it's not a genuine journal to publish their research findings. And at times, or viewers or participants, you must remember, and it not only in your academic world, but also in your day-to-day life, and in the basic principle which will you take you ahead in in your life, that it's always good to be important, but it's important to be good. Let me repeat. It's good to be important, but it's more important to be good. This dressing up the CVs, it doesn't help. Even if you write one article, even if you publish one manuscript in 1 year, in a year, it has more sense if you publish it in a well-reputed, in a well-established journal of your field, than writing 7 to 8 manuscripts in journals, in outlets which have no meaning, or which are categorized as predatory or bogus or fake ones. So sometimes we get succumbed to the big CV. We want to pad up our CVs with the number of publications, with the number of conferences, with the number of technical sessions which we chair. In fact, these are all worthless. And you waste your time, you waste your precious time in attending those conferences, those technical sessions, in chairing those technical sessions. You waste your money, which and you gain nothing out of it. Rather, your purses become lighter, you waste money, you waste time. And cognizant researchers, sometimes they know that these are fraudulent journals and conferences. Still, they publish and attend. Why why do researchers do that? It is sometimes it also happens that researchers submit their research to some well-established journal. They get rejected. So just to get published, because they say they don't want to waste their manuscript, they publish it in some predatory or bogus or fake journal. So that means when they face rejection from the established journal, they try to get published in fake or bogus journals. And early career researchers, because they are ignorant, but then publication is a mandatory requirement, and then they want to publish. That's why sometimes they take recourse, or they resort to publishing in predatory journals and attending predatory conferences. Then sometimes what happens when researchers want to advocate some research which they know peer-reviewed journals will not accept, then they publish it in predatory journals, or present papers and get published in conference proceedings. Then everybody must be aware that because of this publish or perish syndrome, also the researchers try to publish their manuscript wherever they can. But what does that mean? That all promotions, all recruitments, all appointments, when they are linked to all grants, they are linked to number of publications which you have. But then you should also remember that all those bodies, all those granting bodies, all those promotion granting bodies, they also consider where you publish. As in one of the initial slides I showed, I underline that where you publish, where you get published is equally important. So you must remember Though publish or perish syndrome is one of the reasons, then viewers, you must know, you must understand that where you publish is also very important. And while submitting your manuscript, you must take care of all these parameters. I already talked about this, dressing up our CVs through participation, and it is worthless. Chaired a technical session, delivered a keynote address at international conference. It may sound very bombastic for you, maybe in an initial phase, or maybe even if you are in an advanced stage of a career, it may sound very bombastic that I went to Los Angeles and chaired a technical session and delivered a keynote. But the ones who are sitting and who are going to evaluate your work, they know what is the worth of visiting Los Angeles and and chairing a technical session. So viewers, with no intention to comment on anyone, but to share, but to drive home message that while you are applying for conferences, while you are trying to attend any conference, you must make sure that when you are investing your precious time and when you are investing your money, your grant, you must ensure that where you are going to attend is a genuine one. And then lack awareness. Researchers generally, when they lack awareness, when they are not aware of these things, then they fall prey to predatory journals and conferences. Then whenever you are in doubt, it's always advisable to consult your seniors. You may consult your seniors. When you are doubt, you may consult your supervisor, you may consult your teachers, or you may consult your library staff. They always know it, and they are in a better position to guide you with regard to journals and with regard to conferences which you should follow. So now I talked about the various sources which may help you in identifying the right journals for your manuscript, for your research findings. Then we talked about why do they publish in predatory journals and why do researchers attend predatory conferences? Sometimes they do it because they want to dress up their CVs. They succumb to the lure of writing in their CVs, delivered a keynote address, chaired a technical session, and so on and so forth. Sometimes they do it because they are completely ignorant. So what are the adverse effects of publishing in predatory journals and conferences? You see, the very function of journals, which I talked of any journal article, the very functions are defeated. That means when you publish in an authentic one, you register a claim that you are the first one to report what you are reporting. So when when you publish in predatory journal, publishing in predatory journal is as good as not publishing at all. So your registration, you don't get to register. In original journals, what happens? Your work is certified that it is fit enough, it is ultimate, it's definitive, fit enough to be cited. But in predatory journal, when no peer review happens, that your work is not, is not certified. Then dissemination. In original journals, through original journals, your work is disseminated to a global audience. In predatory journals, you never know. Tomorrow they may vanish. Sometimes they are just fly-by-night operators. Sometimes they may vanish. So you will not, you will lose money, and it will not be there for, for future. It will not be a permanent record forever. So these very functions are defeated. These very functions are not addressed, are not taken care of when you publish in predatory journals. And another important thing which you must know is that when researchers indulge in any kind of, when they cut corners or when they indulge in any kind of misconduct or use falsified data or manipulated data, then they try to publish it in predatory journals. So when when researchers do that, then naturally no new knowledge is generated. when you are using false data, when you are using manipulated data, when you are using distorted data, then the very purpose of undertaking research is defeated. Then no new knowledge is generated, rather wrong knowledge is generated, which does more harm to the society. And remember that, because whatever research you do, you don't start abruptly. You build upon the research findings of the previous researchers, and what you report as research findings becomes the foundation of future research. Remember that you build on the previous existing literature, and your research findings will be used as foundation of future research. That means your research findings will be used by researchers who will come up tomorrow. So when what you report is wrong, whatever you report is based on manipulated, falsified data, that means wrong knowledge becomes the foundation of future research. And then what happens? The grant which you get, the money which you get is all wasted. Government money is wasted, because you are generating wrong information which is getting published and which is becoming foundation for future research. So this is another website which is you can use, Think, Check and Submit, to find out the right journal for your work. Think, Check and Submit helps researchers identify trusted journals and publishers for their research. Through a range of tools and practical resources, this international cross-sector initiative aims to educate researchers, promote integrity, and build trust in credible research and publications. Then think, check, and attend. Choosing the right conference to attend and present your research. This is another website which helps you in deciding upon the right conference. Then there are various documents. UGC has published various documents. You should at least go through them. You should be in the know of these documents. You should be in the know of these policies. Then only, it will help you in becoming a successful and accomplished researcher. For example, in September 2020, UGC has published a guidance document which known as Good Academic Research Practices, which is entitled as Good Academic and Research Practices, and it highlights different norms and procedures and ethics which must be followed in different stages of research. While it highlights how you should be conducting a review of literature, it highlights how you should be framing your research questions, it highlights what procedure you should be following in formulating hypothesis, what norms you should be following in actual conduct of your research, what norms you should be following while you are reporting your research findings. It also emphasizes that when you undertake any research, or when you are conducting actual research, maintaining proper record, documentation, journaling is all very important, which should be taken care of. And this document also talks of that publishing in predatory journal is a big no-no. And then UGC, promotion of academic integrity and prevention of plagiarism in higher educational institutions, regulations 2018. All researchers should be in the know of the main components of these regulations. These regulations talk of that the universities should spread awareness, should take efforts to educate users what is all about practicing honesty and ethics in research. And then it mandates publication. Of course, it's a mandatory requirement that it mandates the use of anti-plagiarism software. And then I'll say that it is onus is on all the stakeholders. It's very important for the researchers to stay aware, to keep abreast of the latest developments of their fields, of the latest, of the right publications of their fields. Then at the same time, the supervisors or the teachers, they are also supposed to, little bit of hand holding, guiding their mentees, guiding their students in how to navigate the scholarly communication, how to do their work, and how to report their work. And then authorities or the administrators, they have the duty, they have the onus of ensuring compliance of all these regulations, UGC regulations. And then library professionals also have a tremendous role to play in this, that they need to organize awareness sessions, they need to educate researchers with regard to what is right, and what is the right journal, what is the right way of getting published, and what are the norms which need to be followed. All these awareness sessions need to be organized. I think library professionals have a special role to play as I think it's equally important for the researchers to remain proactive and attend all the sessions, all the awareness sessions or orientation sessions which libraries organize to educate, to enlighten the readers. So I want to drive home that what is important is that you should not be running after certificates for the, you should not inquire all the time ki certificate milega ki nahi. What is more important is that what you gain out of these workshops, what you gain out of these webinars. And you, of course, only one webinar or one seminar will not completely transform you, but gradually you will pick up many things, many new things. You will become aware, you will become sensitive to these things, and I think in the process you will end up as an accomplished researcher. And then you must remember that when you become an accomplished researcher, it's your responsibility to mentor, to guide your junior ones. So you must remember, all the viewers, you must remember that you cannot say when you land up, because even you must know that even publishing in predatory journals and attending predatory conferences also attracts penalty. Remember that. You cannot waste government money in publishing in predatory journals or in attending predatory conferences. So you cannot say when you are caught, you cannot say that hame pata nahi tha. So remember that ignorance is no longer bliss. It's no bliss in academic and research activities. You need to confirm, you need to evaluate, you need to scrutinize before submitting your publication manuscript. You need to confirm, you need to scrutinize, you need to scan before attending any conference. So say no to predatory journals and conferences, and work hard, put in your efforts, give in your 100%. And I again repeat, though I may sound very didactic kind of thing, but then this is the message which I want to drive home, and that is, it's good to be important, but it's important to be good. So you should be aware, and that is all from my side for the time being.
Sir is joined, ma'am.
Acha, sir is here. Okay.
Yes, ma'am. Sir is here.
So we still have 5 minutes, no? So sir,
Yes,
अपना वो सर अभी सेट कर लेंगे ना अपना तब तक.
Stop sharing.
Good morning, sir. Good morning, sir.
Good morning, sir.
Good morning, sir.
Yeah,
Yes, sir.
audible.
Ma'am, stop sharing.
Okay. Stop sharing. तो
It's there.
it's off, no?
Yeah, it's off now, ma'am.
Madam is over?
Yes, mine is over. We still have 5 minutes. Sir अपना set कर लेंगे तब तक. Or if we
Okay.
have some questions for 5
Yeah.
minutes.
Yeah. Okay.
And there is one.
Madam, I am having one question to you, madam, respect to the predatory journals.
Yes.
Because the government has taken lot initiative, lot of awareness created in the research community, faculty members and everything. And most oftenly we hearing that we should not have the publications in the predatory journal, right? But how do we prevent? Because most of the, as we said, predatory conferences become the household in. See, you know me know you. We club together. We can organize. We can have a editorial conference. For that, we can use for promotions purpose or any placement purpose. So, how do we can really prevent being a responsible information science professional? So, this is my question to you, ma'am.
You are asking what is the onus of
Yeah,
library information professionals? Yes.
how do we prevent? Yeah.
I think the basic function of library and information professionals remain the same as it has been for for ages together. We are basically supposed to advocate right things. Our purpose is to disseminate right information. So we need to make them aware what is the detrimental impact of publishing in predatory journals. We need to spread awareness about the consequences of publishing in predatory journals, about the consequences of attending predatory journals. We need to make them aware with regard to different components of different UGC regulations. So, in order to answer your queries, our responsibility or onus on us is to spread awareness with regard to harmful effects of these journals. We need to impart training and education with regard to various key components of different UGC regulations and policies which are in place. In a nutshell, our responsibility is to educate, is to spread awareness through these kinds of sessions.
Madam, why I have told is because I know one guy. He is just doing his PhD. He is having the publication of 50 to 60 articles. Even though I am having 2 decades of experience, I have not tried because I am having hardly 5 to 10 of research paper publications. So this is where may difference. Why they are paying 1,500 and 2,000? Today morning they are sending the paper. Evening, same day evening, they got the confirmation of it has been published. Next day they will click the link. It has been appeared.
So this is the wrong side. This is the double
Yeah.
side. Turnaround is just 24 hours.
Madam, not 24 hours, within 4, only the matter is when they receive the payment, it's enough.
Oh, yes. So this is wrong.
Hmm.
And this is where our role lies, in spreading awareness and telling. And then I think it is onus on everyone, because library professionals cannot by themselves do. They can merely spread awareness. But if authorities are also support in ensuring compliance to these regulations, then I think
Madam. In
it's
this
the
regard,
responsibility of all stakeholders, I'll say.
correct, madam. In this regard, your 1 hour presentation has enlightened everything and comprehensively have been covered. Thank you for having wonderful session for respectfully research scholars and students. They have to must aware about the predatory journals and predatory conference.
Yes.
Ma'am, you will take questions later on after the session or?
नहीं, अभी तो सर शुरू करेंगे ना, तो इसलिए we will take after, no?
Okay, ma'am. Thank you, ma'am.
Moment I'll be online.
Yes, sir.
Sir, your video is not visible. Shipraji, can you hear me?
Yes, you are audible.
You are audible.
No. That Navin sir is not, video is not on. Just you can cross check. Just check with sir. Does he facing any difficulty?
He's connecting. He said he'll be online in a minute.
Yeah. Okay. Just you can cross check with him.
Can we start?
Yes, sir.
Yes, sir. We request you to start.
Okay. Thank you very much.
Good morning, Navid sir.
Good morning.
Yesterday it was very insightful session.
Thank you very much. So today I'll be starting with, in fact, I have to breeze through a number of topics before I start sharing with you, and we will see that how to exactly run various tests which we require for the purpose of writing a research paper or a doctoral thesis. And I'll be limiting myself to say, I'll try my best to share with you about the regression, about factor analysis, about ANOVA, about t-test, and also, how to go in, how to go about doing an analysis which we refer to as the multiple response analysis. And I'll share with you that the situations in which we require that kind of analysis, because at times we encounter a lot of difficulty in analyzing those responses which we have generated using a questionnaire. So first I'll share with you a questionnaire which we discussed in the last workshop that we had in the month of August. So maybe some of you may not have attended that. So I'll first share with you so that you have an idea that what exactly we'll be discussing. Then I'll also be quickly sharing with you various types of descriptive statistics. I'll be sharing with you about hypothesis testing. Yes.
Sir, sorry for interruption. We can't see your PPT.
No,
you are not shared.
I have not yet started.
Okay, sir. Okay.
So,
one more thing. Do you covering H factor index in citation? You are going to covering or what?
No, that I'll not. I think Manorama ma'am can take up that particular.
Okay, sir. Okay.
I'll not be covering that.
ये hypothesis का और थोड़ा सा formulation और levels of significance.
Yeah, that I'll share. Okay. So I'll be covering these issues. So let me start with the as a warm-up session. So I'll start with why and where exactly these things fit in. So first I'll share with you something about data preparation, because so we get an idea that how we will be proceeding further. So let me share with you my screen. Okay. We have ANOVA also, but no, I'll share with you only, yes, this part. So some terminologies very quickly about which we should be aware of. So we have variables which are referred to as independent variables. Then we have variables which are referred to as dependent variables. So for example, in an experiment, variables which are manipulated by the experimenter, they are called independent variables. And depending on the context, remember, depending upon the context, an independent variable sometimes may also be referred to as a predictive variable, a regressor, a covariate, a manipulated variable, explanatory variable, exposure variable, and so on. So these are the various types of terminologies which are being used in the literature. You will find in the research papers and the textbooks, which basically are referring to the independent variable. So the independent variables, sometimes may also be referred to as exogenous variable. So in fact, dependent variable, if you now move to dependent variable, so it is the event expected to change when the independent variable is manipulated. So whenever we are looking for change, we look for change in the dependent variable. Now, dependent variable may be referred to as response variable, regressant, criterion variable, predicted variable, measured variable, explained variable, experimental variable, responding variable, outcome variable, target variable, label variable, and so on. So generally you will find the terminology dependent, but I've shared these various terminologies so that if you come across them, you should not get confused. So in fact, in the context of economics, endogenous variables are usually referencing to this target. So variables may also be referred to as in the form of continuous or categorical, which in turn may be binary, dichotomous, nominal, categorical, ordinal. So I'll not be discussing because we have covered this in detail in the earlier interactions that we had in August. So it is possible, in fact, to have multiple independent variables and multiple dependent variables also. I'll not go again into details because this is part of what we discussed earlier in August. So now I'll move on to data preparation. See, when we have collected data, that's not the end of the things. And generally we are very happy, once we have designed the questionnaire, we think 50% of the problem is solved. Once we have generated the data, we start thinking that 90% of the problem is solved. But in my opinion, unless you're very careful in handling the data which you have with you, and unless you are imaginative, you will not be able to effectively use the data which you have generated. So when you are, for example, generating data using a questionnaire, we have to be clear as far as the checking of that questionnaire is concerned in the context of editing the questionnaire, the coding the questionnaire, transcribing the questionnaire, cleaning the data which you have generated, and then of course you have to use some kind of data analysis strategy to handle that data which you have generated. So transcribing can be short-circuited by using, for example, web-based questionnaires, where what happens is that at the back the data is being stored in some kind of database. So the mistakes that as researchers we commit, for example, in transferring or transcribing the data from the sheet of paper onto some software, that can be minimized. I don't think we can altogether eliminate that, but at least I can claim that we can minimize that. So we have to check the questionnaire. Again, I'll not discuss this in detail because we have already covered this. We will edit the questionnaire. We have to code the question. Be very careful as far as the coding part of the questionnaire is concerned. By coding, I mean that what kind of code have you used for a mail? For example, in your questionnaire, you may have some kind of demographic related question where you're asking that what's your gender. So the gender may be, for example, the person says I'm a female, so you may have coded that as a 2 or a 1. So you have to be very clear, and you have to remember what kind of coding you have used. So for that, we maintain a code book, and nowadays there are softwares which help us in maintaining this information for us. Then as I was discussing with you, transcription involves physical transfer of coded data from questionnaires onto some kind of software or electronic medium. So for that, we can have Markson's forms, for example, the OMR sheets. All of us are aware nowadays. The OMR sheets in which our responses are recorded when we are, for example, appearing for a test. So that can be transferred using an OMR reader. So this physical transfer is avoided by this particular process. Then we have to be clear about the cleaning part also, the data cleaning. Now, in data cleaning, remember that a lot of checks can be performed by us. Some of these activities can be automated by us. By automation, I mean that you can instruct the software that your scale has values ranging from 1 to 7. For example, 1 is for a strongly disagree and 7 is for a strongly agree. So by mistake, if you are keying in an 8 or a 0, so you can instruct the software that it will give you a prompt that you have entered a wrong value, and it can caution you then and there before you move on to the next sheet, or you start doing some other task. And this particular mistake will be recorded in your database. It will be part of your database, and it may create some problems later on. So to avoid that, you should be performing checks. So you should be performing checks in the context of out of range data which is logically inconsistent. Then, for example, extreme values, they play havoc with your analysis. You have to be clear. Sometimes you have to substitute a neutral value, for example, for a missing value. Sometimes you have to go for imputed responses. Sometimes you have to go for case-wise deletion if you find that a particular respondent has not been very careful in giving you responses, and you find that all the responses are hovering towards the extremes. So basically, it is indicative of the fact that the person really did not understand your questionnaire, or maybe the person willingly provided you that information, and because of that you have the values which are very strange kind of values which are appearing. So you have to decide that whether you will be continuing with the responses from that individual or entity from that case, or you will be going in for removal of that entire response set from that particular individual. Then sometimes you have to perform weighing operation also. By this what I mean is that you have to make the sample more representative. For example, in each case is assigned, suppose, a weight to reflect its importance. For example, heavy users may be given a 3, medium users can be given a 2, and light users, for example, in case of a product, can be given a 1. So it depends upon you as a researcher that what is important for you, and accordingly you can assign a weight to that particular variable, and that weight will be reflected in the final analysis that we'll be carrying out. Now we can also re-specify the variables. Now in this, if you just remind me towards the end, I'll like to share with you that how we can collapse a number of categories at times. By this what I mean is that suppose you have obtained responses using a 1 to 7 scale, where as I was sharing with you, 1 means strongly disagree, 7 means strongly agree, and so this means that in between you have a neutral position. So, and the neutral position will be fourth position will be the neutral position here. So this means that responses from 1 to 3, or in case of numerical values, for example, you are using a scale, so values which will be from 1 to 4, basically they will be indicating disagreement, and those who are the values which fall from 4 to 7, or say any value which is slightly more, that depends upon the researcher how you're trying to categorize that information. So that would mean that it indicates agreement. So in a way what we can do is that we can collapse the categories, and we can instruct the software that if the values are say 5, 6 and 7, we substitute these values with a 1, and values which are less than 4, for example between 1 and 4, we substitute them with a 2. So towards the end, what we can do is that instead of going into, now it depends upon, of course, the design of your study and what are the objectives of your study. But this is one way of collapsing. Another, variable in case of which sometimes we have to go for collapsing of categories is, for example, income bands. We initially thought that we will be able to generate data, say from various income bands, and later at the time of going in for frequency analysis of the demographics related information that we have in the questionnaire, we realized that suppose we had income bands like 0 to 5,000, then we have 5,001 to 10,000, 10,001 to 15,000, 15,001 to 20,000. So we realized that very few responses have emerged, say between 0 to 5,000. So we can collapse these, and we can add them to responses, say between 5,001 to 10,000. We will say that we will collapse, and we will come up with a new category, a new band, income band, which will be from 0 to 10,000. Similarly, we can collapse the categories from say 10 to 15,000 and 15,000 to 15,001 to 20,000, and we can have say a category, say 10,001 to 20,000. So this collapsing of categories also sometimes is very interesting and very meaningful. It helps you in better analysis of your data. Sometimes you require this. For example, if you want to go in for t-test analysis, you want to go in for ANOVA or whichever test you are trying to use. Because what happens is that if there are, if you have, that kind of dispersed information before you, it may not be at times very helpful from the point of view of analysis. So we can go in for a scale transformation. Also, we can convert one type of scale into another. We can go in for dummy variable, creation, so that also is possible. We can go in for a scale transformation, as I was sharing with you. We can convert, for example, the data that we have generated using a 3-point scale into another type of scale. That is also possible, and I've discussed that again in the earlier interaction, so I'll not be discussing that again here. Now next, I'll quickly breeze through the descriptive statistics, because that also will be required by us. Is it visible on the full screen? Hello? Hello?
Yes, sir. Yes, sir, it is visible.
Okay. So the descriptive statistics, it's a summary statistic, basically. Remember, descriptive statistics is a summary statistic that quantitatively describes or helps us in summarizing features from collected information. So how do we distinguish it from inferential statistics? Because it aims to summarize the sample here. Descriptive statistics, it aims to summarize a sample. So descriptive statistics, unlike inferential statistics, is basically not developed on the basis of probability theory, and are frequently non-parametric statistics. Now, some common terms which keep appearing before us, for example, are mean, median, and mode. So these are nothing but measures of measures of location. So central location in a way. So measures of variability are range, interquartile range, variance, standard deviation, and coefficient of variation. So measures of variability, that what kind of variability exists in your data. In case you are interested in finding out, exploring variability, you can provide information pertaining to range. You can provide information regarding interquartile range, then variance, standard deviation, and coefficient of variation. Similarly, we have to be clear about these terms of skewness and ketosis. These are measures of shape. So very quickly, what is mean? Mean in sometimes you will come across certain texts, they will use the terminology of average also for this. So data, we can generate means in case we have collected data using interval or ratio scales, and you have the formula before you. This is how we calculate this mean. Now, as far as mode is concerned, see, mode is the value that occurs most frequently. On your screens, you will find that we have agree 23 individuals gave the response of agree. As far as neutral is concerned, 38. So here we can say that this second value, that is 2, is the modal value, because this is the value which is occurring most frequently. So it represents the highest peak of the distribution, and it's a measure of central tendency as far as nominal data is concerned. Now, as far as median is concerned, median, middle, you can remember that using that median of a sample is the middle value when the data are arranged in some order. So it can be ascending order, it can be descending order. So measures of central tendency for ordinal data. Okay. So and median is the 58th percentile. Then we have measures of variability, as we were discussing. We have range, interquartile range, variance, and or standard deviation, and coefficient of variation. So what is range? Range is nothing but largest minus smallest. So it measures the spread of the data. So it is nothing but simply the difference between the largest and the smallest values that we have in the sample. As far as interquartile range is concerned, so it is called the mid spread. So middle 50% of the values, or sometimes in certain texts you will find, or in research papers, this is also referred to as the H spread. So it's a measure of statistical dispersion, basically. Remember this. Then see, this is an example of interquartile range. We have a list of numbers, say 5, 7, 4, 4, 6, 2, 8. Suppose we arrange them in some order. Only then this is possible. We arrange them in order, and we divide them into quarters. See, we have the lower quartile, we have the middle quartile, we have the upper quartile. So what is the interquartile range? Q3 minus Q1. So that will give us the interquartile range. Now, what is variance? So see, the difference between mean and an observed value is called the deviation from the standard mean. All of us are aware of this. Now, variance is the mean squared deviation from the mean. Variance is the mean squared deviation from the mean. So in fact, remember that because it's a squared value, so variance can never be negative. So when in fact we have our data points clustered around the mean, the variance is said to be small. If they are scattered, then the variance is said to be large. As simple as that. So again, now standard deviation, it's the square root of variance, and a standard deviation in a way, we can say it is expressed in the same units as the data rather than in squared units, and this is how we calculate the standard deviation. Now, as far as coefficient of variation is concerned, it's the ratio of the standard deviation to the mean expressed as a percentage. So and because it's a percentage, it's a unitless measure. Then we have measures of shape. So skewness is there. You may have come across this term earlier also. So it's a characteristic of a distribution that assesses its symmetry about the mean. So skewness is basically the tendency of deviations from the mean to be larger in one direction than in the other. So this is an example, say where we have a symmetric distribution here. So it is not skewed. Now, but see, look at the right hand side figure. Now this is a skewed distribution. So we have a skewed distribution. So what happens is that a characteristic of distribution, that what is the skewness? That assesses its symmetry about the mean. So in a symmetric distribution, what will happen is the mean, median, and mode, they are equal. They are not different. They are equal. But in a skewed distribution or asymmetric distribution, what will happen is the mean, median, and mode will not be the same, as it is as is clear from the right hand side figure before you. Now, similarly, you see this is referred to as the left hand side figure is the negative skew. and the right hand side figure is the positive skew. It's representing the positive skew. So for the purpose of understanding, I've shown. I hope that if you come across this term negative skew, positive skew, at least you can make out that what exactly the researcher is trying to share with you. Then there is a term ketosis. The ketosis is a measure of relative peakedness or flatness of the curve. So in fact, ketosis of a normal distribution is 0. So if ketosis is positive, then what happens is that distribution is more peaked. Now let us look at this figure. See here, general forms of ketosis. So the green one is the normal one, mesokurtic, normal one. The blue one or magenta is the platykurtic. So it is depressed. It is less than what we should be normally having. Leptokurtic is peaked. It is having a peak. It is more than normal. So let us look at again the description of these various types of ketosis. So if ketosis is positive, then distribution is more peaked than the normal distribution, and is called leptokurtic. So sometimes it is also referred to as leptoketotic. So leptokurtic is the most commonly used term for it. Now negative value, as far as ketosis is concerned, it means that the distribution in comparison to normal is depressed or flatter. So this is referred to as platykurtic or platyketotic. So platy means broad and lepto means slender. So this is how you can remember. Slender is, it will be more than, it will be positive, it will be overshooting the normal one, it will be above the normal. So wherever you have this positive ketosis, you will find that it will be more slender. It will be more, the curve will be more slender. If it is negative, you will find that it is flatter. So this is how you will find that it will be represented. Okay, these are the various texts which generally are referred to as far as my presentations are concerned. So if you're interested, you can have an idea. See, I refer to these textbooks. Okay, then let me just share with you. Yes. So is the screen visible? Full screen?
Sir.
Is the full screen
Yes,
visible?
sir. Yes, sir, it's visible.
Okay. I'm just asking because yesterday something strange happened. So I don't want,
sir.
I should be continuing and you say that I was just not visible.
Yes, sir, I understand.
Okay. So so we have certain terms that we'll be using. So you should be aware of these terms. We have terms like population. We have terms like parameter. We'll be using sample. We'll be using statistic. So how to remember them? Population, P for population, and P for parameter. So parameter, whatever estimates they are related. They are there before you. They are related to the population. As far as sample is concerned, we have a statistic. So S is for sample, S is for statistic. So it's a summary measure. Statistic is nothing but the summary measure about the population. Now, now Madam was asking Manora ma'am about hypothesis testing. So I'll try my best to share with you whatever I know about hypothesis testing. So first of all, maybe the approach that I'll be adopting may be slightly different from what you may have come across as far as earlier texts are concerned, but I'll see to it that whatever I'll be discussing, it will fit into and it will, I hope, clarify a number of misconceptions about hypothesis testing. So first of all, so see, suppose we consider an example, and I'll be sharing with you and clarifying terminology also that we use in the context of hypothesis testing. So I'll not be discussing this in detail because again, I'll share with you that we discussed this in detail during the last interaction in August. So I'll not cover that, but very briefly. So let us look at this. See, how do we go about testing the hypothesis? So first of all, we state the hypothesis. See, whatever. Now remember one thing, that SIS hypothesis, SIS is used for one hypothesis, and SES is used for multiple. So hypothesis, SES is plural, SIS is singular. So hypothesis, we state the hypothesis, whatever hypothesis we wish to test. And what's a hypothesis? Hypothesis is nothing but a conjectural statement. It's some kind of relationship which you are imagining that exists between the variables of interest. So then we set the criteria for a decision. As far as hypothesis testing is concerned, we set the criteria for the decision. And then what we do is that we compute a test statistic and then we make a decision. In short, this is what we are doing when we go for hypothesis testing. But things are not so simple. Let us go deeper into this hypothesis testing. See, what we are doing is that we begin, in fact, by stating the value of a population mean in a null hypothesis. Now comes into picture a term, null hypothesis. And we assume that null hypothesis is true. This is the assumption. Null hypothesis is true. So we start by assuming that hypothesis or claim that we are testing is true. And generally, this is referred to as the null hypothesis. Now, when we say null hypothesis, I would like to go a bit into detail regarding this. So see, it is represented by H, capital H generally. And we may be having a subscript 0, which may be used to represent this. So H with the subscript 0 is generally used to represent null hypothesis. So what does the null hypothesis say? Null hypothesis states that there is no difference between the groups that are being studied. I'm repeating. Null hypothesis, what it states is that there is no difference between the groups that we are studying. So in other words, we can say that there is no relationship, say, between, suppose we are trying to find out, we have data from males in a particular class, we have pertaining to age, and we have data pertaining to age from the females also who are part of the class. And suppose we want to find out that are there any differences as far as the mean scores in terms of age are concerned vis-a-vis the males and females. So the null hypothesis would be that differences do not exist as far as the mean age is concerned in the context of the two genders who are right now part of your class. So remember that what basically is happening is that if you are a researcher, remember that you should not be alarmed if you find out that there is no difference. If you find out that there is no difference based upon your analysis, because as a researcher, our job is not to present a particular picture only. Our job is to present whatever we are finding based upon the data that we have generated, whatever data we are playing around with. So our job as researchers is not to present only one particular view, because the moment we try to present this and we get happy or we get annoyed if our hypothesis null hypothesis is supported or not supported. So suppose alternate is supported and null is not supported. So we should not be alarmed, because our job is to present as things are. Our job is not to in any way manipulate the data and then present those findings. So now the counter to this null hypothesis or the other term that keeps appearing along with null hypothesis is the alternate hypothesis. Now this alternate hypothesis is generally denoted by H1 or HA, and this is subscript. We have in subscript form you will find HA being used or H1 being used. Remember, we discussed that H0 is used in the context of null hypothesis. H1 is used in the context of alternate hypothesis. So of course, it's very obvious that alternate hypothesis is nothing but the logical opposite of the null hypothesis. I'm repeating, the alternate hypothesis is the logical opposite of null hypothesis. So in fact, the alternate hypothesis states that there is a difference between the groups. So whenever we are dealing with alternate, see, the null says no difference, null no. Alternate is the logical opposite. So when it is the logical opposite, it would mean that there is a difference between the groups. When we are saying in null hypothesis there is no difference, so in alternate it would be that there is a difference. So in fact, we should be presenting, I'll keep repeating that, as things are. So HA is, if we say that HAA is true, it means that that there is a difference. There is a difference between the groups that we are trying to study. So you can only reject a hypothesis and say that it is a false hypothesis, or we fail to reject a hypothesis, so it could be true, but you can never be totally sure. So remember that whenever we are going in for hypothesis testing, we should not be using the terminology we accepted the null hypothesis. So we will be using the term rejected, not rejected, supported, not supported, because in the recent terminology, in the recent research papers and textbooks, you will find that they avoid using the term accepted. In the earlier textbooks, you will find, and research papers, maybe they may have used, but the recent trend is that we do not use the term accepted as far as hypothesis testing is concerned. So Now this takes us to, okay, I've already covered this. I've covered this. So I have an example before you right now. Yes. So we have suppose an industry representative, because this will also help us in clearing doubts about the one-tailed and the two-tailed test. Suppose an industry representative claims that mean household income per month in Delhi is a certain figure. The certain figure, suppose it is 4,400. So it is an imaginary figure, please, for the purpose of understanding this particular concept. It doesn't mean that it is the actual figure. I don't know what is the actual figure right now. So suppose this is the figure that we are dealing with, that the mean household income per month in Delhi is this. Now there is a developer, suppose of a shopping center or some kind of facility, and that particular individual, or there is a researcher who wishes to test this claim. And how does he wish to test this claim? The person will be contacting a certain number of households. Suppose in this case it is 36 households which that individual contacts, and will be comparing the obtained sample mean with the claimed monthly mean. And what is the claimed monthly mean here? 4,400 rupees is the claimed monthly mean. And the person will be generating data from certain number of households. Here we are taking 36 households, suppose. It can be 40, it can be 100, it can be 2,000. It depends upon you as a researcher, how many households you are able to contact. Now, developer wishes to reject the claim only if it is clearly contradicted by the sample results, and thus claimed monthly mean of rupees 4,400 is given a benefit of doubt and assigned H0. So H0 is given the benefit of doubt, and H0 is what? It is the null hypothesis. So how will we be stating this? So see, we have before you H0 or mu is equal to rupees 4,400, and what is the alternate hypothesis? It can be a value which can be less, or it can be more than 4,400. So this is a logical opposite of the null hypothesis. I'm repeating, null is equal to, because this is what we started with. This is what we started with, that the mean household income. See, we did not start with this understanding that it is less than 4,400 or more than 4,400. We started with this, that it is equal to 4,400. So the null hypothesis is rupees, that mu is equal to 4,400. And alternate hypothesis is that it is not equal to, logical opposite of the null hypothesis. So the parameter value associated with H1, that is the alternate hypothesis, are all possible values that are not included in H0. And what will be those values which are not included in H0 and null hypothesis? Values less than 4,400, values more than 4,400. So if we reject the null hypothesis, that is H0, we will be automatically in a way accepting the alternate hypothesis H1. That will mean, and what will that indicate to us? That mean that would mean that monthly household income is some value other than 4,400. So if sample results do not support H0, we accept the alternate hypothesis, that is H1. Please pardon me if there is some problem as far as, because H1 last is not appearing, 1 is not appearing as a subscript. It's a typo from my side. So H1 may be non-directional or H1 may be directional. So if situation, now what is this directional and not directional? If situation does not call for direction, H1 is considered to be two-tailed. So if it does not call for a direction, in our case, you will find that it can be a value which can be less, it can be a value which can be more than 4,400. So H1 can be 4,400 less, it can be less than this, or in the other direction, it can be more than this. So the other thing that we do is that we set the criteria, that is, we set the level of significance. Okay. So now what is this level of significance? Now this level of significance, remember, it is the value alpha or the alpha. So how it, in fact, all of us, will be familiar with the term P that we use in the context of, or the P value that we use in the context of hypothesis testing. I'll discuss that, in detail. Just wait for some time. So see, how do we determine the value of P? That whether P is low or high? Then here comes into picture the concept of level of significance or alpha. So alpha is the, now this in fact takes us to the concept of type 1 error and type 2 error. So, so just wait for a minute. I'll cover that slightly later. So yes. Just a moment. Okay. Okay. I'll first show you. Yes, I'll show you. I'll discuss from this. It's type 1 and type 2 errors. Let me come down to this, and then we will discuss that. Okay. Now this basically is summary of all that we are going to discuss. So in fact, let us, before we proceed further, let us look at what does type 1 error mean, because that is connected to the current discussion that we are having. So when your data fools you into rejecting the null hypothesis, even though it's true, it is called a false positive or a type 1 error. So in fact, what we mean by type 1 error, in other words, is that you are incorrectly rejecting the null hypothesis. In short, this is what we are saying here. That type 1 error is that, in short, we are rejecting the null hypothesis. Then the researcher says there is a difference between the groups when there in reality is no difference. So in reality, there is no difference, but we are saying that there is a difference. If we are committing this kind of mistake, basically we are committing an error which is referred to as type 1 error. So it can be thought of as false positive. False positive. So usually we are more concerned about this null hypothesis or type 1 error because at times, as researchers, we try to show that a difference exists between the groups, though that is not our task. I was sharing with that thing earlier also. So if there is any intentional, for example, or maybe unintentional bias, it may exaggerate the differences between the groups, and the probability of making a type 1 error is called alpha. I'm repeating, the probability of making a type 1 error is called alpha. Now this alpha will be used by us in the context of, again, hypothesis testing later on also. So please remember this. What is alpha? Alpha is the probability of making a type 1 error. So now how you can remember this? You can remember this by thinking that alpha is the first letter in the Greek alphabet, and one is type 1 error is the first type of error that we are discussing. So type 1 error, so it goes with type 1 error. That is, alpha goes with type 1 error. So then we have the type 2 error. Type 2 error. So type 2 error, in fact, refers to when you means basically what does it mean? That is, you fail to reject the null hypothesis when you should have rejected the null hypothesis. So let me remind you again. So always we'll be discussing, or we'll be trying to explain various terms in the context of null hypothesis. See, we are not dealing with alternate hypothesis. We are not using the term alternate hypothesis when we are defining these terms or explaining these terms like type 1 error, type 2 error. All through we are using or discussing them in the context of null hypothesis. So type 2 error, let me repeat, is when you fail to reject the null hypothesis. So this is what it means. Failing to reject the null hypothesis, even though it is true, is a false negative. In the previous case, type 1 error, it was a false positive. Now positive comes, remember that type 1 error is associated with positive, false positive, and type 2 error is associated with false negative. Type 1 error is associated with alpha, and we will see that type 2 error is associated with beta. So beta is the second letter in the Greek alphabet. So it is one way of easily remembering that what is beta. Beta is nothing but type 2 error. That is how we can easily remember it. So the researcher basically says that there is, in case of type 2 error, what we are doing is the researcher is saying that no difference between the groups exists, whereas there is a real difference between the groups. So now in the context of null hypothesis we are discussing. So the probability of making type 2 error is beta. I'm repeating, the probability of making a type 2 error is called beta. So remember that you can, as far as this type 1 error and type 2 error are concerned, and so this will lead us to something more interesting that we'll discuss later on. So you can remember this, again I'm repeating, by relating them with the Greek alphabet. Type 1 alpha, type 2 beta. Type 1 basically is related to that you are rejecting the null hypothesis even though it's true. Type 2 error is that you are failing to reject the null hypothesis even though it's not true. So in fact, in type 2, basically what you're doing is that there is, as a researcher, that you are saying that there is no difference between the groups that you are studying, whereas in fact there is a real difference. I'm saying there is a real difference between the groups, that it is not because of chance. It is the real difference that exists between the groups. Now, as far as type 1 and type 2 errors are concerned, and before we proceed further, there is one more term which is appearing here, in fact, is power. Just see the right hand side, down below in the last cell, right corner, power. Now it is 1 minus beta, 1 minus beta. So power is nothing but the probability of finding a difference between groups if one truly exists. I'm repeating, power is nothing but the probability of finding a difference between the groups if a difference truly exists. It is not a false, a wrong, or maybe an error on our part. No, we are referring to that the difference really exists. So it is the probability. Power is the probability of finding a difference between the groups that we are studying, and if a difference really exists, that if one truly exists. So in fact, it also can be said to be a percentage chance that you will be able to reject the null hypothesis if it is really false. I'm repeating. In other words, you can say that it is the percentage chance that you will be able to, or you will be rejecting the null hypothesis if it is really false. So power, in fact, can also be thought of as the probability of not making a type 2 error. I'm repeating that power can also be thought of as the probability of not making a type 2 error, not making a type 2 error. So how do we represent this in equation form? This is before you, 1 minus beta. 1 minus beta is nothing but power. So it is good, for a particular study to have high power. So in other words, generally it is said that having a beta less than 20% for a study is considered to be good. Now, having a beta of less than 20% for a study is said to be good. Now, by default, what it would mean is that 1 minus 0.2, that is 0.8. So the power should be hovering around 0.8, because 20% it would mean 0.2 for us. So it is 1 minus 0.2, that will be 0.8. So remember that this is how we are interpreting it. So a cutoff for differentiating high or from low power would be roughly around 0.8. So if it is less, so we will say that it is low power. If it is more than 0.8 or 0.8, we will say that it is satisfactory, or we will be basically saying. And now, what are the things on which it would depend? See, this, if the sample size increases, remember, if the sample size increases, then what happens is the power of the test generally improves. As far as the differences between the groups, suppose they are large, then the power of the test would improve or increase. If the precision of results improves, then we will be having improved power. If the standard deviation is low, then again would be having more power. Now this is how we report our results. So another thing is that, see, as we are now, one question that may be coming to your mind is that how does increase in sample increase the power? See, what happens is that when the sample size increases, you have more data from which you can make a conclusion. So that is why we say that it leads to increase in power. So let me repeat that power also increases as the effect size. Now this I use a term, one term, the difference between the groups. So in technical terms, we can say that if the effect size increases, then also the power increases. So in fact, the actual difference between the groups is nothing but the effect size in a way, you can say. So if you are trying to detect huge difference between the groups, it will be very easy for you than detecting a very small difference between the groups. It's very obvious. So increasing the precision, and by increasing the precision, what it means is that we are trying to decrease the standard deviation, or it will lead to decrease in the standard deviation. So increasing the precision of your results will also improve the power. Now let us look at how we report our results. Now, before this, we have a term p-value which is appearing before us. So before I start sharing with you that how do we report the results, let us have a look at what do we mean by this term p-value. See, what is p-value? P-value is the probability of obtaining a result at least as extreme as the current one, assuming that null hypothesis is true. Now it may sound a very strange kind of explanation which I'm giving to you, but in simple terms, we can say when we are using the term, this p-value, another way in which we can explain this concept of p-value is that assuming that null hypothesis is correct, p-value is the probability that if we repeated the study, the observed differences between the group averages would be a certain value that we started with. I'm repeating. So P-value is a measurement to tell us how much the observed data disagrees with the null hypothesis. In short, in very simple terms, we can understand this, that P-value is a measurement to tell us how much the observed data disagrees with the null hypothesis. So now this has implications from the point of view of hypothesis testing. I'm repeating that it tells us that how much the observed data disagrees with the null hypothesis. Observed data is whatever you have generated from the point of view of your study. So when the p-value is small, when the p-value is very small, there is more disagreement of our data. If the p-value is very small, with disagreement with what? With the null hypothesis. So let me repeat. Then the p-value is nothing but a measurement to tell us how much the observed data disagrees with the null hypothesis. So if the p-value is small, then there is more disagreement of our data with the null hypothesis, and we can start thinking of rejecting the null hypothesis. Now, in other words, when the p-value is very small, our data is suggesting to us that it is less likely that the groups being studied are the same. I'm repeating. If the p-value is very small, then what our data is telling us is that it is less likely that the groups that we are studying are the same. What it is telling us is that the groups that we are studying are different. They are different. They may be different in terms of the mean age. They may be different in terms of income. They may be different in terms of some characteristic of interest that we are trying to study. So therefore, when the p-value is very low, remember what we are saying is that our data is incompatible with the null hypothesis and we reject the null hypothesis. In fact, that is what is presented before you on the screen. So if the data, if the p-value is very low, our data is incompatible with the null hypothesis and we tend to reject the null hypothesis. Now, if the p-value is high, this means that there is less of disagreement. There is less of disagreement between our data and the null hypothesis. If the p-value is high, there is less of disagreement between our data and the null hypothesis. So in case the p-value is high, it is more likely that the groups that are being studied are the same. I'm repeating. In case the p-value is high, there is greater likelihood that the groups being studied are the same. So let us again go through this. If the p-value is very small, what it is telling us is that depending upon the data that we have generated, that it is p-value is telling us that the data, the null hypothesis would be that differences do not exist. The two groups are the same. So if the p-value is very small, it is telling us that our data is not supporting the null hypothesis. What it is telling us is that no, there are these two, groups are not the same. If the p-value is high, what it is telling us is that it is supporting the null hypothesis in a way, and it is telling us that yes, these two groups are not different and they are the same. So in this scenario, we are likely to fail to reject the null hypothesis. So by definition, in fact, alpha level. Now here comes into picture the term, the concept of alpha. Now alpha is one more term that will be appearing and that appears in the context of hypothesis testing. So by definition, alpha is the probability of rejecting null hypothesis when the null hypothesis is true. So by definition, so this is another thing that we have to keep in mind is that the p-value is basically the probability of obtaining your sample data if the null hypothesis were true. What is p-value? It is the probability of obtaining your sample data if the null hypothesis were true. This is another way of saying what we are discussing. So if we obtain, for example, a p-value of 0.85, p-value, we have obtained this 0.85, then you are very obvious. You have, in fact, no reason to suspect or very little reason to doubt the null hypothesis. So, however, if, for example, you have a p-value of 0.01, 0.03, now then there is only a very small chance that you have obtained data if the null hypothesis was in fact true. So, and since the p-value is the probability, just like alpha, p-value ranges from 0 to 1. So this is what you will come across, that it will be ranging, it will never be having a value which is more than 1. So right before you on the screens, you have p-values, for example, 0.1, 0.01, 0.05. So in olden days or golden days or earlier days, when people looked at p-values in printed tables, they would report the results of a statistical test as p is less than this, p is equal to this, and so on. But currently what is happening is that because we are using various types of softwares or statistical programs, they give us an exact p-value that is based upon the test which has been performed, such as p is equal to 0.029. And I'll suggest that report it as such. Do not report it in the form less than or greater than that. This description can be provided by you in the description of your results. But as far as reporting is concerned, report it as p is equal to this, because this is what the software is giving us. So you will conclude that results are either significant or they are not significant, and they are either reject the null hypothesis, or you do not reject the null hypothesis based upon this p-value that we just now discussed. So we at times may also use these values to indicate the strength of the relationship, or the strength of the difference. So people in fact may also want to know if your results are strongly significant or they are not strongly significant. So p, for example, is much less than 0.05, so then we can say that strongly significant. So some of the researchers at times, while reporting their results, they also use this kind of terminology, that it was strongly significant, it was not strongly significant, and so on, based upon the kind of p-value that appears before them in the statistical program or the software, for example, like SPSS, Minitab, or whichever software we are using. Okay, so I've covered this, but before I move further, there is another term that will be appearing in the context of hypothesis testing that I would like to share with you, and that is the level of significance, or alpha, that we just now discussed. So you see, alpha, what exactly it means. When we are saying p-value is high, p-value is low, so how do we determine this high or low value? So here level of significance will come into picture, or level of significance or alpha will come into picture. So alpha, in fact, we discussed that alpha is the probability of making a type 1 error. Alpha, if you recall that we discussed previously, that alpha is the probability of making a type 1 error. Now if it is selected, in fact a selected cutoff point that determines whether we consider a p-value acceptably high or low. So this is what basically it is telling us. So if our p-value is lower than alpha, remember, if our p-value is lower than alpha, we conclude that there is a statistically significant difference between the groups. I'm repeating, if the p-value is lower than alpha, we conclude that there is a statistically significant difference between the groups that we are trying to study. So, and how do we define alpha? Alpha, sometimes this question is asked, alpha is arbitrarily defined. For example, a 5% level of significance is the most commonly used level of significance as far as social sciences are concerned. As far as medical sciences are concerned, this level of significance may be increased further. For example, we can go in for 1% level of significance. Why? Because there in social sciences, it's not a matter of life and death, whereas in medical sciences, it is a matter of life and death. Sometimes we need to be very sure, we need to be very convincing, and that is why researchers may be using a different level of significance in case of medical sciences or maybe other fields of study. But in social sciences, we generally use 5% level of significance, and it is arbitrarily defined. So, by definition, remember that alpha is the probability of rejecting a null hypothesis when the null hypothesis is true. This is what we discussed initially. So, in fact, in simple terms, we can say that what is this alpha? Alpha is the probability of making a wrong decision. I'm repeating. What is alpha? Alpha is the probability of making a wrong decision. So when we say that it's the probability of making a wrong decision, and one more, another manner in which this can be, or this has been in fact discussed by certain researchers, is what they do is that they have tried to present it, say, confidence level plus alpha is equal to 1. So this is in fact, they say, fact 1 of your hypothesis testing. So if alpha equals 0.05, then your confidence level will be 0.95. I'm repeating, if alpha is equal to 0.05, that is 5% confidence significance level of significance you are starting with. So then your confidence level would be 0.95. So if you increase alpha, you both increase the probability of incorrectly rejecting the null hypothesis, and you also decrease the confidence level. So when we say confidence level plus alpha is equal to 1. So if alpha equals to 0.05, your confidence level will be equal to 0.95, and so on. So we have discussed this. Okay. So in brief, what we can say is that when we say deal with confidence interval, remember that confidence interval is the range of likely values. I'm repeating, confidence interval is the range of likely values for a population parameter. If you recall, we discussed P's for population, P's for parameter. Confidence interval is the range of likely values for a population parameter such as the population mean. So for example, if we have say 95% confidence interval for a certain value that we have, then 95% confidence, then it means that we are 95% confident that the interval contains the true average value of whatever we are dealing with. So I think with this basic understanding, I'll move on to the next part of my interaction. I'll again come back to this when we will be actually testing the hypothesis using various tests. So let me. Okay. Because I'll be starting with the use of MRA or multiple response analysis. So very quickly, let me share with you a screenshot of the questionnaire that I'll be using so that you are able to understand that. Yes. Yes. Okay. So this is the questionnaire, in fact, that I'll be discussing in the context of multiple response analysis. So if you look at question number 4, I'll be, in fact, using this question number 4. And what is the question number 4? Let me just blow it up. See, which of the following toppings do you typically prefer? Now, this is a study which pertains to preferences vis-a-vis, an eating joint. So suppose for the purpose of academic understanding, I'm using the example of Domino's Pizza. It is in no way reflective of the current reality for the purpose of understanding only. So let me caution you, in no way I mean to convey this that in any way Domino's is having a positive, people are having a positive impression or negative impression about it. So for the purpose of understanding, I'm repeating. So questionnaire is that, so the first question is that, did you purchase a Domino's Pizza last month? So you can say yes, no, I'm sure, I'm not sure. The last time that you bought this pizza, is that you have it delivered at your home, or it was at your place of work, or you picked it up yourself, and so on. And in your opinion, what's the taste? So we use poor, fair, good, excellent. And the fourth question is very interesting. Which of the following toppings do you typically order? Which of the following toppings? So in case of pizzas or such things, you have toppings which are placed, you like to place on that pizza and you like to consume. So see the description, see the instruction which is given to the respondent. Cross all that apply. Let me just blow it up. Let me just blow it up. See here what I mean. Which of the toppings do you typically prefer? We are instructing the respondent, cross all that apply. So we are basically encouraging the respondent to give us more than one response as far as this question number 4 is concerned. By more than one response, what I mean is that theoretically somebody can put a tick mark or cross or indicate preference, or maybe not preference as such, that typically I've ordered nearly all of them. Theoretically, it's possible that green pepper, onion, mushroom, anchovies, pineapple, chili flakes, and so on, all of them have been consumed by me. So I can put a cross on all of them. There may be certain respondents who may give a response of the type which is there before you on the screens. That is in case of that they preferred black olives, oregano, and basil. They preferred this only. Some of them may indicate that I prefer onion only. Some of them may prefer that I prefer onion sometimes chili flakes, sometimes parsley, and so on. So various types of combinations will be appearing before us. So as researchers, at times we encounter difficulty in how to analyze this kind of data. So for that, I'll take you to how we can do this using SPSS software. Is the screen visible? My SPSS data view?
Yes, yes, sir.
Okay. So Now see, there are two views as far as SPSS is concerned. This is for those who are not very familiar with the use of SPSS or who have not used SPSS. There are two views. One is the variable view and the other is the data view. Now in the variable view, what I have done is that I have indicated here beforehand so as to save on time. I have already indicated that, see, question number 4, if you recall, we discussed that various types of toppings were listed there, right from green pepper to parsley. So what I've done is that for question number 4, when you are entering this kind of information or entering information pertaining to variables which are like, our question number 4, you have to treat each of the response that is emerging as a separate variable. And that is why you will find that each of the response has been stored in a separate row here. In SPSS, when each row of the row, basically represents a variable. So if I, switch to the data view, you will find that it is appearing here, question number 4.4, 4.5, 4.6. Now, why I'm using 4.4, 4.5, 4.6? If you recall the questionnaire that we discussed, in that questionnaire, we are dealing with only question number 4. And in the questionnaire on the left hand side in the variables list, it was mentioned that green pepper is the 4th variable and parsley was the 13th variable. So that is why I have used here question number 4, question number 4.4, 4.5, 4.6 up to question 4.13. So now here again, let us look at this variable view. In variable view, see, all the options that we had provided, they have been entered by me in the label column. So the options that you provide, or for example, it can be male and female. So I'll be using the term gender in that case here. In this, had it been for males and females, or for example, gender variable, I would have used the term label here, gender. And where will I enter whether the response is from a male or female? For that, I'll go to the values. So here in our case, if the person has given me a response that the person has consumed or typically consumes green pepper as the topping, so I have entered it as a 1. So 1 means yes, 0 means a no. So if the person left it blank, I would assume that the person is trying to convey to me that this particular type of topping or this option is not applicable in the case of that individual. So I'll be treating that as a 0 or a no. So how I do it? Let me just repeat it. Let me just remove it so that I give you an idea that how we enter it. Suppose we are using 0, 0 for no. So I'll enter a 0 first and I'll enter a no and I'll give add. So now it has entered 0 is equal to no. Then I'll give 1 here in the value and I will say yes. Yes. So I will add. Now it is 0 is for no and 1 is for yes. Now similarly, I have done this for all of them. I have done this for all of them. Now for the purpose of understanding, SPSS also allows you to copy this for all of them. Suppose I can copy this and I can then highlight all of them and simply paste it. So I don't have to repeat this operation of giving values again and again. So now let us come to the data view. So I've entered some hypothetical or imaginary data. So what basically this indicates is, let me just toggle the view. So it is telling that as far as this, respondent number 1 is concerned. Now this row contains data from respondent number 1, suppose. Now this respondent number 1, as far as 4.4 is concerned. Now what is 4.4? See, 4.4 for me means green pepper, green pepper, green pepper. So the person has said that yes, green pepper has been ordered, or sometimes the person has consumed a pizza with this kind of topping. Similarly, the person has consumed pizza with the topping onion also. How we can say this? Because the person has given me a 1. And similarly, you will find that for all of them, the person has either given me a yes or no. I think we don't have, of course, it's imaginary data for the purpose of understanding. So theoretically, somebody could have given me a 1 for all of them. Now, how will that be recorded by me? I'll be recording a 1, 1, 1, 1, 1, 1, 1, sorry, 1, 1, 1. So see, I'm not entering, sorry. Yes, 1. So I have entered, I've created right before you another entry, imaginary entry from 13th respondent. So suppose this is the 13th respondent. Now, interestingly, the 13th respondent has given me a 1 for all of them. So I said theoretically it's possible. We have just done it and we have seen that yes, it's possible. Now, how to analyze this? Sometimes you have to present in tabular format that what is the cumulative picture? What is the picture as far as these various types of options which have been selected by respondents are concerned? So how do we analyze that? So what we do is that we will go to analyze option. We will go to analyze we will go to multiple response analysis. I'm repeating. We will go to analyze. In spaces, analyze option. In analyze option, we will go to multiple response. In multiple response, we will select define variables. In fact, that's the only option which is activated right now. So I'll say define the variables. So I'll just click to see right now what's appearing before us. Green pepper. See, green pepper is, let me just make it bigger. Okay. See, green pepper is 4.4, onion is 4.5, mushroom is 4.6, and so on. So these are the various types of toppings that we had entered in this. So now what we can do is that we have to first of all shift all of them. We have to shift all of them. So what we can do is that we can select this first one, and we come down, we select this. Variables instead, then what we have to do is that before proceeding further, we will say that count which values, count those values where in our data we have a value of 1. Though categories are also possible, that is beyond the scope of discussion. I'll right now be limiting myself to counting values. That suppose the person has given me a 1 means a yes. So I will use the term name, I'll give toppings in short. So I'm basically trying to study toppings. So I'll give add. Now see, toppings get transferred to add, gets transferred to the multiple response sets. I'll give a close here. And now see what happens. Now when I come to analyze again, and I go to multiple response sets, now you see frequencies and crosstabs, both of them have become active. So I'll repeat this for those who have not been able to follow, but let me just complete this cycle once. I'll go to frequencies. Frequencies, I will transfer this to the tables. I want a table to be generated, and I'll give OK. Is the output table visible to you? Is the output table visible?
Yeah, sir, it's visible.
Okay. So we have 13 respondents in our case. So in the case summary, you have 13. And see, as far as the topping frequencies are concerned, see, it has the software. We could have instructed the software to arrange in descending or ascending order, but right now what we have before us is that, see, it is giving us a summary table where all of them have been presented, that what are the responses, what are the percentage responses, which of the toppings is most preferred, which of the toppings is least preferred. The entire information, based upon whether we got a yes or a no from the respondents, is summarized right before us in the form of a table. Now, for those of you who want to use this table directly for the purpose of presenting it in your research papers, there is a provision where you can remove. Suppose you want to remove percent of cases. You don't want this to appear in your output. So you double click on this image. This will appear, and then what you do is that you highlight this. See, I'm double clicking on this image. You again click on percent of cases, click on the right mouse key, and select this. Sorry. What you do is you select the data cells. It will select the data cells below this, and then what you do is that you say cut or delete. So it has made it shorter. So this SPSS allows, and similar softwares, they allow us to basically manipulate the output table. Not in the negative sense I'm using the term manipulate. You can have a cleaner table, and then you can copy this table directly from here. Now, for example, you click outside this window, then you can copy this, and in copy, what you can do is that you can copy from here, and then you can take it to the Word table or whichever software you're using, and you can paste it directly there. So you can paste it in the form of an editable table, or you can paste it in the form of a picture also. These options are also, they appear while you are pasting. So for the benefit of those who could not follow, I'm closing this output window. I will again repeat the operation. See, very briefly, what we did was that we had a questionnaire. Let me just show to you this. Is my PPT visible to you? Hello, is the PPT visible?
Visible.
It's visible. Okay. So see, this is where we started with. We are dealing with only question number 4 of this questionnaire. We have a question where multiple responses are possible. More than one response can emerge. So this is, suppose the case that we're taking up is the toppings in case of a pizza. This is the question that we are playing around with, and we have entered the data pertaining to this in this particular SPSS data sheet. And in the variable window, what we did was, this is open another one. Yes, this is what we have with us. We have the green pepper, onion, and so on, various labels we have provided. In the values, what we did was that we instructed that 0 would mean a no and 1 will mean a yes. So because we are interested in counting all the yeses, then what we did was that we went to the data view. In fact, we can do it from the variable view also. We can go to analyze. We can go to multiple response sets. Then what we did was that we instructed the software. We transferred all these variables into the variable window. Then we instructed the software that, okay, count the values which are ones. Then we gave a certain name to it. Sometimes some researchers, they fail to give a name, and then they say that it is not moving further. So always give a name to the variable response set or multiple response set that you wish to generate. So we gave a name, say toppings. We gave a name toppings. Then we added this here, okay, because it's already existing. So we can give a different S. If I give an additional S, it will now think that it's a different variable. So it has stored, though it is the same. So we remove it and then we close it. Then we again go to analyze. We go to multiple response. We go to frequencies, and in frequencies, it will appear something like this initially. So then you can transfer this to the tables window, and you can you give OK command. This is the output table that you get. Okay. Now, this was about the MRA or multiple response. So before I proceed further, I would like to discuss with you now something about the t-test and ANOVA, because I'll be demonstrating that also, and how to interpret the output in case of SPSS. Is the screen visible? Understanding t-test and Z?
Yes, sir.
Okay. So very briefly, I'd like to walk you through the difference between t-test and z-test. So do you know that population standard deviation? If it is yes, and then the next question that comes to our mind, if it is no, we use the t-test. If it is yes, is the sample size above 30? We use a z-test. Yes. If it is no, we use a t-test. Now remember, in most of the softwares that we use,
sir, I think we need to change the slides, sir.
Okay. That is what I asked. That understanding t-test and z-test, it's not visible to you?
No, sir.
No, on Excel sheet is there, sir. Still.
Okay. I'll just switch. Please give me. Okay. Now it's visible.
Yes, understanding t-test.
Oh, understanding t-test and z-test. Fine. So, because sometimes even in Vivas, this question is asked that what's the difference between t-test and z-test. So, is the sample size above 30? If it is yes, you can use a z-test or z-test, and if it is no, you can use it. You are supposed to use a t-test. So in fact, t-test you will find is the default test that appears in the software that we use nowadays. So this distinction is getting increasingly blurred. Only for academic purposes, people are nowadays discussing the difference between t-test and z-test, and that is why I've done it. But let us move to the t-test, because before we start using t-test and ANOVA, some basic understanding should be there that what exactly is happening behind the back. So in fact, what does t-test do? T-test assesses whether the means of two groups are statistically different from each other or not. See, we can find out the differences otherwise also by simply calculating the differences, or by calculating the mean scores. For example, from males, we find out we ask all the males, for example, in a particular group to share with us their age, and then we can find out the mean age. All the females who will be there in that group, we request them to share with us their age, and we find out the mean age. So it can tell us that, okay, whether the mean score as far as males is concerned is higher or females is higher. But what we cannot tell is whether this difference is statistically significant difference or not. It is for that purpose that we require the t-test. So the t-test assesses whether the means of the two groups are statistically different from each other or not. So in fact, this analysis is said to be appropriate whenever you want to compare the means of two groups. Now, for this, I would like to walk you through some terminologies which will be appearing again and again. So let us look at this, that what basically is t-test doing. See, we have, 3 graphs before us. Medium variability. Now, this is an ideal kind of situation. Now, we have high variability. You will find that the graph is depressed. It is not following ideal representation, or the curve that we have before us is a depressed kind of curve where we say that high variability exists, and here we have slender curve. So here what we say is that there is low variability. So these 3 scenarios for differences between means let us consider. So now what implications does it have from the point of view of the t-test? So the difference between the means is the same in all the 3, you will find, is it not? So you see the dotted lines, they represent the differences between the means. So the differences are the same as far as these 3 representations are concerned. But when we are looking at differences between scores for 2 groups, we have to judge the difference between their means relative to the spread of variability of their scores. So in fact, t-test exactly helps us in doing this, that it also accounts for this spread. It accounts for the spread. And that is why we use this. Now, another interesting thing that t-test is helping us do is, see, the t-test is nothing but, you can imagine, signal upon noise. Now, signal is something which is good and noise is something which is bad. So the difference between the group means is nothing but signal, and noise is the variability of the groups. So the more the variability, more the noise. So in the previous case, in the high variability graph that you have before us, the noise is more in comparison to the first one, in comparison to the last one. So t-test is nothing but signal upon noise. So the formula, remember, for t-test is a ratio. The top part is the difference between the 2 means or averages. The bottom part is the measure of variability or dispersion of the scores. Now, what is variability? Remember, the variability is nothing but the dispersion of the scores. For example, somebody gave me an age that in my group that my age is 80 years. Another person gave me an age, say my age is 5 years, or my age is 10 years. So now the variability will be high in comparison to another group where, for example, the people are giving me age which are closely packed. For example, the ages, none of them has an age which is more than 50, and none of the persons in the group has an age which is less than 20. So in that case, it will be more closely packed in comparison to a group where the one person is having an age of 80 and the other person has an age of 5 years. So there the variability or the dispersion would be more. So bottom part, is called the standard error of the difference. Basically, this is how we basically technically represent this bottom part. Now, how do we understand this? See, the t-test uses a procedure to boil all the sample data that you have down to one value that is referred to as a t-value. So calculations, what they're doing, they're comparing your sample means to the hypothesis. And what is the hypothesis? Null hypothesis is that differences do not exist between the 2 groups that we are trying to compare. Now, why I'm saying 2 groups? Because in t-test, we tend to compare only 2 groups. If you want to compare more than 2 groups, then we move on to the ANOVA, or analysis of variance procedure. So calculations compare your sample means to the hypothesis and incorporates both the sample size and the variability. This is the beauty of the t-test. So a t-value of 0 would indicate that sample results exactly equal the null hypothesis, if this is what you are getting. So in statistics, we call the difference between the sample estimate and the null hypothesis the effect size. So now effect size has appeared twice. If you recall, we discussed initially, in another discussion that we were having about effect size. So as the difference as this difference increases, the absolute value of t also increases. So a t, to test the significance, you need to set a risk level which is referred to as the alpha level that we have already discussed. So I'll not go again into that. So now when to use a t-test? If the sample size is less than 30. There are certain assumptions when we are using a t-test. Now, one of the assumptions is that data set should be independent from each other, except in case of a paired sample t-test. Now, what is a paired sample t-test? Very briefly. So if 2 readings are emerging from the same individual, suppose, from the same subject, then we have to go for a paired sample t-test. If the readings are independent of each other, then we go for independent sample t-test. Now, another to illustrate better, what is paired sample t-test? Suppose what is happening is that we have a group of individuals, and this group of individuals is administered a drug, and before administration of the drug, which is, for example, which can help in lowering the blood pressure of individuals. This is what our assumption is, that it will help us in lowering the blood pressure. So you take their blood pressure measurements before the administration of the drug. Then what happens is you administer the drug, you wait for the drug to take its effect, and suppose the drug requires suppose an hour to take effect. After an hour, you again take measurements from the same group. So what is happening is that two measurements will be emerging from the same group of individuals. From the same, suppose it boils down to one individual, two measurements will be emerging from the same individual. One measurement is pre-administration of the drug, and the other is after the person has consumed that medicine or that medication, and we are trying to study the effect of that medication. So in this scenario, if you are trying to compare the measurements, the blood pressure, for example, that we measured initially and after the administration or the medication takes its effect, so in that case, we'll be using a paired sample t-test. Whereas in most of the scenarios, in fact, I'll say 95% of the scenarios, or the situations in which we generate data and the studies that we do, you will find that we use independent samples t-test only. Now the distribution should be normal. Now this is another assumption as far as use of t-test is concerned, and these assumptions hold true as far as ANOVA is also concerned. So that's why it's important for us to quickly walk through these assumptions. So the distributions, for example, distributions of the two groups, in terms of the data that we are generating, for example, age. So the distribution should be normal for the equal and unequal variance t-test. So, if we are using, so distribution should be normal. The variances of the sample should be the same. Now, this is another assumption. The variances should be the same for equal variance t-test. Now, all individuals must be selected at random. This is another interesting assumption which we generally violate. In fact, we also violate the first one. Equal variances assumed condition is violated. Distributions are not normal most of the time because the samples on which we are relying are not based on any kind of probability sampling procedure. They are based on convenience, or they are convenience samples only. So that assumption is violated. The assumption of variances is also violated, and the assumption of randomness is also violated. So individuals must be selected at random. That too is violated, but no problem. We have softwares which can help us in analyzing such types of data where these normality conditions or these assumptions are frequently being violated by us. So sample sizes should be as equal as possible. By this, what we mean is that suppose, for example, we are trying to compare two groups where one group, the number of individuals are 10, and the other group has, say, 100 individuals. Now, this difference is too much. So this is what we mean when we say sample sizes should be as equal as possible. So it would be appropriate for us to compare 10 with 20, 10 with 30, 10 with 40, but comparing 10 with 1000 will not give us anything meaningful. So that is basically what we mean by this. No, I've already discussed single sample t-test and independent sample t-test. I'll not go into that again. So let us quickly walk through, understand this ANOVA. Now, what is ANOVA? ANOVA is analysis of variance procedure. So, here what we're doing is, see, statistically significant difference between the means of 3 or more groups. That is what we are trying to find out as far as use of ANOVA is concerned. So if we are trying to compare two groups, then t-test is sufficient for us. If we are trying to compare more than two groups, like for example, we want to find out something about, say, we are trying to compare differences between people who are followers of different religions. Something we are trying to compare. So suppose we are followers of Hinduism, we are followers of Islam, we are followers of Christianity. We want to compare these three groups. So now the situation is ripe for us to, and we want to compare the mean scores, for example. And some additional things also, of course, will kick in when we are using ANOVA. So in that case, we'll be using ANOVA. So statistically significant differences between means of 3 or more groups can be studied using this particular procedure. We should not be using t-test because t-test is appropriate for comparing two mean scores only. Now, there are different types of ANOVA. We have one-way ANOVA, we have two-way ANOVA, and so on. So let us quickly see what is one-way ANOVA, because that is what we'll be discussing. I'll be demonstrating that using Spaces software also. So it is used to test whether or not there is a statistically significant difference between the means of 3 or more groups. And see, suppose we are trying to study, different studying techniques. One example that I came across, I found it interesting because it's a general type of example. So suppose the assumption is that the studying technique has a bearing on the examination, the score of the student, for example, in the class. So different types of studying techniques were studied. That is, students were told to follow different methods as far as preparation for the exam was concerned. And these methods were more than 2. So we want to study that effect on the response variable, that is the examination score. That is how much are they scoring in the sessional test or in the exam. So in that case, we'll be using ANOVA. Now there can be another situation. For example, that we have, we want to find out that, is there some connect between the amount of exercise that the person goes for and the gender of that individual. Now, in the case of amount of exercise, there is a possibility that we can be we may be studying individuals who go for no exercise at all, for example, who go in for light exercise, and who go in for a lot of exercise, that is intense exercising, the exercise they go for. So these are the two factors. One factor is level of exercise, and this factor level of exercise has 3 levels. Let me repeat. The factor levels of exercise has 3 levels. Level of exercise. It has 3 levels: no exercise, light exercise, intense exercise. The factor gender has 2 levels: male and female. Suppose this is what we are studying. So now we want to study the effect of this on weight loss. This is the response variable. That do these 2 factors have an effect on the loss as far as weight is concerned? So again, as far as ANOVA is concerned, so see, in this we will be using 2-way ANOVA. In the previous case, we would be using 1-way ANOVA because we have 1 factor. In this case, we have 2 factors. So 2 factors, and each of the factors may be having more than 1 level. Let me repeat. In those scenarios, we use 2-way ANOVA. So for an ANOVA to produce valid results, the following assumptions should be met: the assumption of normality, the assumption of equal variance, the assumption of independence. What is the assumption of normality? All populations that we are trying to follow, trying to study, they must be following a normal distribution. What is equal variance? The population variances in each of the groups are equal or approximately equal. What is assumption of independence? The observation in each group needs to be independent of each other. That is, for example, I hope you will agree that if we are finding out something about the say income of people who are followers of various religion, they will in no way be otherwise connected. So the assumption is that all the measurements that will be emerging will be independent of each other. So usually a randomized design will take care of this. So what is the difference? Very briefly, the t-test measures the ratio of the mean difference between the 2 groups relative to the overall standard deviation of the differences, whereas ANOVA measures the ratio of variance. So that is the core difference as far as t-test and ANOVA is concerned. So ANOVA measures the ratio of variance between the groups relative to the variance within the groups. So variance between the groups and variance within the groups. This is what ANOVA is helping us understand and capture. So t-test can tell us whether or not 2 groups have same mean. ANOVA tells us whether or not the 3 groups, they all have the same mean or not. So, but remember that when you're using ANOVA, I'll demonstrate that to you. When you're using ANOVA, always activate the post hoc test, because that can help you in comparing the means between 2 pairs, that even 2 pairs that you have out of several groups that you are trying to compare. So I'll shift to use of SPSS. Okay. Is the screen visible?
No, sir.
No. Okay. Just a moment. Let me just show to you. Yes. I think now it's visible. I'm showing to you the first label should be Indian people should always buy Indian made products. Is that one visible?
Yes, yes.
Okay, fine. So now let me demonstrate t-test and ANOVA. Now suppose what we have with us is we have certain statements. This is what we generally play around with when we are generating data using some kind of questionnaire. Suppose in this questionnaire we had 17 statements. These 17 statements were related to concept that we have, concept of ethnocentrism, and the descriptors or the labels for each of the statement are right before you. So we have 17 statements on the left hand side, ST1 to ST17, and then just below that we have gender, and below that we have age, then below that we have religion. So let us focus on these 3 demographic variables, and we will try to find out that how exactly we can use whatever we have tried to understand till now as far as t-test and ANOVA is concerned, and how we can use it on the data that we have with us. So in this database you will find that of course let me again share with you one more thing, that see, as far as the responses to various statements were concerned, we use a Likert type of scale in this questionnaire, and this scale range from 1 to 7, where where one meant strongly disagree, and this represented, just a moment. Yes, where one represented strongly disagree, and 2 represents moderately disagree, 3 little disagree, 4 neither agree nor disagree, 5 is little agree, 6 is moderately agree, and 7 is strongly agree. So those of you who were present in the previous interaction in August, we discussed in detail that ideally we should not be having these intermediate descriptors, because we tend to compromise on the quality of data that we are generating. So ideally we should not be having these descriptors. We should be providing descriptors only towards the extremes of the scale. That is, 1 is strongly disagree, and the last one was the 7th one is strongly agree. And why are we using 7-point scale here in this case? In our study, we tried to follow the suggestions given by the original researcher. So the original researchers, in fact, we had an Indian origin researcher who was part of this study. And in fact, they are the people who gave this well-known scale of consumer ethnocentrism, some Shimpen Sharma, and somewhere in 1987. So they use the 7-point scale. That is why we're using, because one question that may come to mind is that why we are complicating the things and using a 7-point scale and not a 3-point scale or a 5-point scale. So we wanted to replicate their work in the Indian settings on various occupational groups. So we have a 7-point scale because of that. So now, so the people may have given us responses of say 1, 2, 3, 4, 5, 6, or 7, as far as these statements ranging from ST1 to ST17 are concerned. Now, as far as gender is concerned, of course, what we have considered is, just have a look at this, male, 1 means male and 2 means female. Now, as far as religion is concerned, see, we have, this is how we are representing religion, followers of Islam, Hinduism, Christianity. This is how we are representing it. As far as income bands are, yes. As far as age is concerned, see, we have various age bands. And we have very, closely packed age bands, 15 to 20, 21 to 25, 26 to 30, and so on. So this was again for the purpose of, going deeper into it, that we try to collect data and try to categorize them in this particular format, that these kind of, age bands for use, and so many age bands were used by us. So now let us come to the data view. So now we have used, as far as gender is concerned, it is one of the variables, or when we are using it in the context of ANOVA, it will be referred to as factor. So we have gender, which has 2 levels. One level is, we have 2 levels. See, one of the level here is, male, the other is female. As far as religion is concerned, it has more than 2 levels. We are trying to represent data in terms of followers of Hinduism, followers of Islam, followers of Christianity, and others also. Now, what is this others? For example, in our study, we found that when we contacted people who were followers of Jainism, they said that do not categorize us, as followers of Hinduism. We want to be categorized separately. So we said, okay, because our objective was not as such to go in for this. Our objective was to capture that what kind of differences exist. Similarly, if you interact, for example, as such, the followers of Sikhism, they are not included because we did not find very many as far as our study was concerned. So we clubbed, for example, followers of Jainism, followers of Sikhism in the others category because of this. So we have, so many levels, as far as more than 2 levels as far as the religion is concerned, and we have 2 levels as far as the gender factor is concerned, or the variable is concerned. So now this is how the data is represented. Now, if I toggle, you will find that little agree, strongly agree, neither agree nor disagree, all these they appear before us. And similarly, if you look at the age, you will find that the various income age bands will appear. And if you look at the religion, the followers of various religion will appear. Now, for the time being, forget whatever is appearing further to the right, that father's education, father's occupation, and so on. Let us not go into that. So this data has responses from roughly 954 individuals. So it's a huge database. It's a real database that we actually use. One of my PhD scholars used for the purpose of her doctoral thesis. So this is a real database. So let us first try to implement or use a t-test on this. See, when we are going in for a t-test, remember that t-test is nothing but comparison of means. This is what we were discussing. So we will go to compare means, this option. Now, again, remember that within compare means, as far as t-test that we are trying to employ here, it is independent samples, because responses which are emerging from males and females are independent of each other. And let us look at the descriptives part before we proceed further, that what is the frequency breakup as far as this gender is concerned. So I'll select only gender, I'll select only religion and age. Let us see what is the breakup, and let us see in terms of okay, let us first go in for a simple profile generation table and see what is happening. That gender, it is telling us that there are 716 males in our database and there are 238 females in our database. For those of you who are not familiar with SPSS, let me repeat what I did. I went to analyze, I went to descriptives, I went to frequencies only. And in frequencies, this kind of window opened. What I did was I transferred these three variables from the left-hand side. Yes.
Sir, your video has been stuck, and also it's not moving. Just you are explaining or something you are doing, changing.
No, I'm changing.
It's not appearing, sir. Here. Just one Excel sheet is there.
Is this window of ST1, ST2 visible to you?
No, sir.
It's not visible.
Your video is also stuck, but only one screen is checking. That one slide what we have put it.
Robust ST1,
is it visible? Am I visible now again?
Yes.
You are visible, sir, but there is no movement. It has been stuck to your video, I think.
Okay. Now is it visible? Now am I moving?
You are audible, sir.
It doesn't appear, sir.
Sir, you are.
My video is not appearing.
Sir, just you can change the slide.
Just a moment. Is this appearing now?
Yes,
hello?
it's appearing.
Is it appearing? Let me close other windows. I think it will simplify the things. Just a moment. Let me just close, because there's so many windows are open. There is some confusion. Just a moment. Now, is this appearing? ST1, ST2?
Yes.
SPSS?
Yes.
Okay. So what I did was that, in fact, let me again explain, because it was not visible. I went to descriptives, first of all, to find out that how many males and how many females are there, or how many followers of various religions are there as far as our database is concerned. I went to frequencies. I clicked on frequencies. Let me reset it. Then what I did was that I'm instructing the software to display the variable names only. I will be shifting gender, age, and religion to the right-hand side window like this. I shift it here. Then I click OK. I'm not touching any of these options. Is this visible now?
Yes.
Okay. So this is the output table. Is the output table visible now? Hello, madam. Is the output table visible?
Sir, I think there is some problem, because I can't see, sir.
Okay, just a moment. There is some break. There is some
yes, sir. Some problem.
There is some break in the link, perhaps because of some connectivity issues. No problem. I can log on using the same URL again. I'll just do that.
Yes. Shipraji? Hello, Shipraji?
Am I there?
Yes, sir.
Okay, I'll just share the screen again. Is the screen visible now?
Yes, sir. ST1, ST2, ST3.
Yes, that is visible.
Visible. I think there was some technical issue, so it was under process.
So now I'll just repeat. So I was demonstrating that this frequency counts I did. So what I did was that I transferred. Let me reset. I transferred these three variables, gender, age, and religion, to the right-hand side window. and I gave OK command. Now, is this visible output window? Hello?
Yes.
So ST1, ST2, it's
Okay,
visible.
output window is not visible. So this means that I have to share the output window also. Just a moment. Can I share two windows also? Or I can share your entire screen. I think perhaps that will be better if I do that. Is it visible now? ST1, ST2?
Yes. Yes.
Yes.
And is this visible now?
Yes.
Yes. Yes.
Frequency
Yes.
stable?
Output
Yes.
table. Yes. Sir.
Oh, okay, output table. So let me just do it again, because for the benefit of those who could not follow me, see, we have descriptives. I selected frequencies, and in frequencies, what I'm doing is that I'm instructing the software to display variable names only, and then I'm moving to, I just reset it. Then I'm moving to the variables regarding which I want to generate, a profile, that how many frequency counts. So I shifted. I give OK. Now, is this visible now? Frequency stable?
Yes. Yes.
Okay. So in this frequency table, you will find that there are 716 males and 238 females. So in all, we have data from 954 respondents. Similarly, as far as age is concerned, see the breakup vis-a-vis age is present here. Then, as far as religion is concerned, we have the breakup as far as followers of various religion are concerned. We are before us. Now, let us try to see that how we'll be using SPSS, for example, in the context of t-test. So again, I have to go to analyze. I'll go to compare means, because in t-test, basically what we are doing is we are trying to compare means, and I'll be activating the independent sample t-test. If you notice, the last option given is one-way ANOVA, because in case of one-way ANOVA also, basically we are comparing the means. The only difference is that in one-way ANOVA, the additional thing is that we are trying to compare the means of more than two groups. So it is, SPSS places this within the category of comparing means, the various tests which are available. So first we will see that how do we implement this independent sample t-test. So in independent sample t-test, what I'll be doing is that, suppose I want to find out that is there any difference in responses of the two genders in terms of the first statement, which is nothing but that Indian people should always buy Indian-made products instead of imports. I think that right nowadays there is too much of talk going on regarding that we should be focusing on products or buying things which are made within our country. So in fact, this attempts to capture that only. So Indian people should always buy Indian-made products instead of imports. So I'll transfer this to the test window. As simple as that. I'm trying to look at it. I'm trying to find out that whether the mean scores which will be emerging as far as this statement is concerned. And the mean scores, remember, we have tried to measure using a 1 to 7 scale. So the mean scores or the scores which or the responses which people have given, they range from 1 to 7. So, and what is the grouping variable? The grouping variable that I will be considering will be gender, the males and females. So I'll transfer gender to the grouping variable. Now see, two question marks are appearing. Sorry, two question marks are appearing. Let me just make it bigger for those who, it may not be very clear. So let me just make it bigger. I hope it is very clear. The question marks are clear.
Yes.
Are the question marks clear after gender?
Yes, sir. Yes, sir.
After gender, we have two question marks.
Yes,
the
sir.
software is basically prompting us to tell us what these question marks mean. So now you have to define the groups. If you recall, we took into consideration 1 means male, 2 means female. So now we have to give that we want to compare 1 with 2. Now why this is being prompted by the software? Because see, we can also use a t-test, for example, on the variable religion and instruct the software to compare any two religions. So it will be helping us compare two religions only. So that is why we can instruct the software that you compare. Now suppose we have coded 1 as followers of Hinduism, 2 as followers of Islam, 3 as followers of Christianity. So we can instruct the software to compare 3 and 4, suppose. So that is why it is prompting us that please indicate which two groups you want the software you wish the software to compare. So we want the software to compare 1 and 2 because we have only two groups as far as gender is concerned. Now we go to this, and then now we have defined the groups. Now we go to options. The options, see the confidence interval percentage is 95%. Now we have already discussed this. Now go to continue. Leave it default. In most of the software, the default value that you will be getting will be 95%. Leave it as such. If you want, you can raise it up to 99%. If you want, you can bring it down to 90%. So the moment you bring it down to 90%, basically you will be changing the alpha value then. Please remember, if you are doing that, basically what you're doing is that you will be changing the values, and accordingly you have to then interpret, because it will be, the interpretation will change, because and you have to be clear about this. The confidence level plus alpha gives us equal to 1. So if alpha equals 0.05, confidence level is 0.95. So here in this case, let us leave it as 95. As 95. Give continue. So by default, we are continuing with this. Give OK. Now this is the output table that has emerged. Now, is the output table visible?
Yes, yes.
Okay. So we have group statistics first. The first table that is appearing before us is the table which is giving us group statistics. So we have males 716, females we have 238. Now look at the mean scores. The mean scores for males is 4.27. For females it is 4.21. So visually it appears to us that there is a difference, but we don't know whether this difference is statistically significant difference or not. For that we will be looking at table number 2, that is independent sample t-test table. Now look at the second table. In the second table, the first 2 columns, they are connected or related to Levin's test for equality of variances. So if you recall, we were discussing in the assumptions that the variances should be equal. So Levin's test for equality of variances basically helps us in doing this, that variances should be equal. So if this value, remember this value in case of Levin's test, the significance value or the p-value, it should be more than 0.05. If this value is less than 0.05, then there is a problem. Now t-test, the other value, so it had, if equal variances assumed condition is satisfied, we look at this significance value, two-tailed significance value. If this condition is being violated, then we look at the second row, the values which will be appearing in the second row. Incidentally, in this case, both the values are the same, 0.716, 0.716. I'm looking at these values. These values are the same. So this is happening in this case, but it may not happen in all the cases. So, and here, another thing that you have to keep in mind in the group statistics is that, see, the data is closely packed. Why? Because standard deviation values, in a way, they are, if you compare in terms of the 2 genders, they're similar. The standard deviation values are similar. So now we look at this 0.716. Now remember that we started with this assumption that the p-value that we'll be considering will be 0.05. Now this means that now this value, had this value been less than, I'm looking at the 0.716 value under the column significance two-tailed. P-value here is 0.716. Now this value is more than 0.05. Now because this value is more than 0.05, and see, the null hypothesis would be that significant differences do not exist between the 2 genders in terms of statement number 1. That is, Indian people should always buy Indian-made products instead of imports. In fact, this would be your hypothesis. So in a way, you are testing your hypothesis. The hypothesis would be that significant differences do not exist between the 2 genders in the context of, or in terms of, such and such thing, whatever is the variable which you are trying to study. So this is your output that you are getting, in fact 0.716. Now had this value been less than 0.05, then if you recall, we discussed that if p is less than 0.05, then our null hypothesis would be rejected. If p is more than 0.05, this means that our data is supporting that. So in fact, what it is telling us is that as far as the 2 genders are concerned, that is males and females are concerned, their responses vis-a-vis statement number 1 are more or less the same. Though mean scores appear to be different, but these scores are not statistically significant. These differences are not statistically significant. So we can say that as far as males and females are concerned, they stand at equal footing vis-a-vis their responses to statement number 1. See, this is what we should be inferring. Now, it doesn't mean that now there should be no excitement as far as we as researchers are concerned because no difference has emerged. See the interesting part here. What it is telling us is that as far as males and females are concerned, they are at equal footing as far as buying things which are made within your country is concerned. So now you can't say that females in any way are preferring products which are foreign made products. What this data is telling us is, and what we are inferring from this t-test results is that no, as far as these two groups are concerned, that is males and females are concerned, they are at equal footing as far as their responses to a certain statement. And in this case, it happens to be that Indian people should always buy Indian-made products instead of imports. So this is how we will be interpreting this. Now let us move to ANOVA. I'll take questions, of course, later. I'll quickly move to ANOVA. Now, as far as ANOVA is concerned, I'll continue with this same output window. See, I'll go to compare means. I'll go to a one-way ANOVA. Now, in one-way ANOVA, this kind of window will open. Let me just blow it up so that if it is not clear to some of you, you get an idea of what we are doing. I hope now it's better. So now in one-way ANOVA, what we'll be doing is that, see, we can compare more than two levels, a variable which has more than 2 levels. So here we will try to compare as far as the religions are concerned. So first of all, let us continue with the first statement. We can select all these statements in one go also, but it will complicate the issue. So I'm selecting only the first statement. So I'll select the first statement and shift it to the dependent variable list. Now here, instead of variables, we have the dependent list. Now, as far as religion is concerned, it will be shifted to the factor window, factor variable, option here. Now I'll go to post hoc. If you recall, I said initially that we should be selecting some post hoc test. Now, if I don't select the post hoc test, I'll tell you, because we don't have time. I'll explain to you in the output itself what will happen had we not selected the post hoc. Now, see, the significance level by default is appearing 0.05. You can lower it or you can higher it. If you want to higher it, you can make it 0.1. If you want to lower it, you can take it to 0.01. So depending upon what is the research design and what kind of topics or what is it that you're trying to study. So I've selected Sheffer test. Now Sheffer test, if you look at the explanation or the description under which the Sheffer test is given, see, it is equal variances assumed. Equal variances assumed. So incidentally, in the t-test, we found that equal variances assumed condition is being satisfied. See the options here. Equal variances not assumed.
Raghvendra ji, there is some problem in the connection.
Hello? 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 Is the output window not clear? Hello? Hello?
Shipra ji? Shipra ji?
I think there was a break again.
Yes, sir.
I think again I'm online back. I'm back.
Yes, sir.
Okay, no problem. I hope this output window is visible.
Yes, sir. Yes, sir.
When is it that we lost the connection, so that I can repeat that part?
Sir, you were talking about post hoc test, which we have to.
Okay. So see, the post hoc test is activated by clicking on this option here. So in the post hoc, let me blow up the window again, and see, in the post hoc, if you note, you will find that we have several options. See, equal variances assumed. We have LSD, Bonferroni, SIDAC, Sheffer, and so on, Tukey, and so on. So any of them you can select. I generally select Sheffer. So now see, equal variances assumed condition is already, we know it is satisfied, because in the t-test results we found that equal variances assumed condition was satisfied vis-a-vis the variable that we are considering. It may be so that in case of other variables, for example, other statements, this condition may not be satisfied. So as a researcher, we are supposed to find out whether equal variances assumed condition is being satisfied or not. And in fact, for that, you will note that t-test allows us to go in the second table, the Levin's test for equality of variances results are appearing, and using those values, we can infer that whether this condition is being satisfied, that is, equal variances assumption is being satisfied or not. If they're not satisfied, then there are procedures. For example, equal variances not assumed options are also there as far as the post hoc procedures are concerned. But because our condition is satisfied, and even otherwise, even if it is violated, these tests which are there, they are so robust. The algorithms which the softwares are using are so robust that they help us in covering the errors that we commit as researchers as far as data collection is concerned. So I'll go to continue. I'll leave the significance level as such, and let me go to options. So in options, I will select descriptives. I will select, then I will not select any other, continue, and I give OK. Now remember that we have selected the first statement, that is Indian people should always buy Indian made products instead of imports, and I have shifted religion. Religion has more than 2 levels. It is, we have tried to capture data pertaining to several religions. So it has more than 2 levels. It is termed as factor in this context, and I have shifted the religion variable to the factor option here, and I give OK. Now this is the output which we are getting. This is the output for one-way ANOVA. I hope this is visible. One-way
Yes,
ANOVA output.
yes, sir. Yes, sir.
Okay. So if you look at this one-way ANOVA, you will find that we have a descriptive table. It is telling us that how many respondents we have from each of the religious group. So we have 290 followers of Islam, 610 followers of Hinduism, 38 followers of Christianity, and we have 16 who are others. So the mean scores for each of these followers are also presented. We find that 4.3 is for followers of Islam, then 4.26 for followers of Hinduism, for Christianity is 4.11, and so on. The standard deviation values are also presented. Now, if you look at the ANOVA value here, now ANOVA, this table is telling us, the significance value is telling us is that significant differences do not exist. Why? Because this value is more than 0.05. So had this value, significance value, where double click is appearing right now on your screens, had this value been less than 0.05, then what we would have inferred is that significant differences exist between some of the groups. Between, see, we really, it may be all the groups or it may be some of the groups. So what it simply tells us, what this value tells us in ANOVA output is that significance differences exist. And if you want to find out that differences exist between which groups, then we have to activate the post hoc test. So see, what is the beauty of the post hoc test? That it helps us in doing something which is similar to the t-test. See, if you want to find out that what kind of differences exist as far as followers of Hinduism and Islam are concerned, so see the significance values appearing here. We are getting a value of 0.996, which is very high if you compare it to 0.05. So what it is telling us is that as far as followers of these two religions are concerned, they stand at equal footing as far as the responses to that particular statement or that variable is concerned. Now, if you want to compare followers of Islam with followers of Christianity, then you have to look at this value, that is 0.964. Now, again, this value is more than 0.05. So what we can infer is that as far as followers of Christianity and Islam are concerned, they stand at equal footing. Now, some of you may argue that while discussing the assumptions, we were discussing that the numbers, as far as the groups are concerned, the numbers should be close to each other. So you will find that in one case we have 610, the other 290, and then we have 38. I was sharing with you that the algorithms and these tests that we are using, they are so robust that they can help us in comparing even these wide differences. Ideally, we should not be taking into consideration these differences. So what we do is that we tend to collapse. For example, we could have collapsed followers of Christianity with others, and we could have increased this number to 16 plus 38. We could have obtained others category, and that others could have been compared with followers of Hinduism and followers of Islam. So this is this output table for the purpose of illustration, for the purpose of understanding. It's okay that we are considering because it is giving us something interesting here. So followers of Hinduism and Christianity, we can compare in this second row. Followers of Hinduism and Christianity. Now, followers of Hinduism and Islam, or Islam and Hinduism, the same results will be appearing here. So, in fact, you will find that there will be repetitions as far as this multiple comparisons are concerned. But the beauty of this multiple comparisons or post hoc test is that ANOVA output table above this tells us or helps us in finding out whether differences are significant or not. And if you want to go deeper and find out that differences exist between which groups, for that we have to activate the post hoc test. So I have discussed, and of course, these are the important things that we are supposed to discuss. I'll now quickly move on to the regression example, so that those of you who want to have a feel of that, yes, please, just a moment. I've just turned off that. I'll again switch on just for a moment. I hope correlation and regression PPT is visible. Is correlation regression PPT
Yes,
visible?
yes,
sir.
yes.
Full screen?
Yes,
Yes,
no,
sir.
not full screen.
It's full screen,
It's
ma'am.
full screen.
Okay. Now I'll directly, in fact, when we are discussing regression, I would like to quickly walk through this correlation also. See, correlation is usually followed by regression analysis. Now, application of this. Now, what exactly we are doing in correlation? Remember, so we are trying to correlate. We are trying to find out that as to whether certain variables that we are considering they are in any way related to each other. So, application of correlation analysis is to measure the degree of association between two sets of quantitative data. So, we can. And while the main objective of regression analysis is to explain the variation in one variable, for example, which is referred to as a dependent variable, and it is based on the variation in one or more other variables, which are referred to as independent variables. So I'll just directly jump on to this concept of dependent and independent variables. So let us take an example. See, suppose we have a case where sales of a product are based on advertising expenses or number of salespeople or number of sales offices or all of these. So we have one dependent variable and several independent variables here. So we can go for multiple regression analysis. So see, correlation is, as we were discussing, is followed by regression. So there are different approaches here. So we have the hit and trial approach. So see, the general regression model that generally you must have come across in textbooks or research papers is something of this type: y is equal to a plus b1 x1 plus b2 x2 and so on up to bn xn. So it can have n number of variables that we are dealing with. That is the independent variable. So y is the dependent variable, and x1, x2, up to xn, they are all independent variables. And they are expected to be related to y, that is a dependent variable, and they are also expected to explain or predict y, that is a dependent variable. So in fact, this is the basic understanding that we are starting with, that we have certain variables which are independent variables, and a variable, suppose we have a dependent variable. And I'll take a practical example also. And b1, b2 up to bn, they're all coefficients of respective independent variables, which will be determining from the data that we will be feeding into the software. So A is known as intercept. So B are the coefficients, A is the intercept, and x1, x2, x3, they're all dependent variables, and y is the independent variable. Now, I'll just directly move on to the example. Suppose we have a manufacturer, and this manufacturer manufactures something, and that something is electric motor, suppose. And we want to build a regression model. Regression model, why we want to build? Because we want to find out that sales is a dependent variable. That on what all is the sales value dependent? What or sales will be dependent on what all things? So what all things the sales will be dependent? It can depend on market potential. It can depend on dealers of the company in a particular area or territory. In marketing terminology, suppose we have a number of salespeople in territory. There may be competitors also who may be operating in that particular territory. So you have to account for those competitors also. So we may be measuring that using some kind of scale. So index of competitor activity that can also be keyed in the regression model. So this is what will be appearing in the output, and we will try to just see very soon that how we implement this. So see, the sales will be appearing something like this. Sales is equal to minus 3.17 plus 0.23 into potential, 0.8 into 82 into dealers, 1.09 into salespeople, minus 1.89 into competitor activity, minus 0.55 into service people, and so on. So all on the right hand side, remember, they are the independent variables. The left hand side figure, that is sales, is the dependent variable. Now let us implement this using the software. Yes, quickly I will start this correlation and regression. Yes, is my window visible? Potent, dealers,
Yes.
people, and so on.
Yes, sir. Yes,
Okay.
sir.
So see, what is this? What we have done is that using scales, we have measured data pertaining to these various variables, that is dependent and independent variables, and they have been. This is how we have defined this in terms of the variable window. This is the sales potential. These are the number of dealers. These are the number of salespeople you have. This is the description. This is the competitor activity. This is the number of service people. This is the number of existing customers that you have, and this is the sales territory. Now, I've taken this example because most of us are familiar with this kind of terminology which is being used in everyday life. that we have dealers, we have salespeople, we have competitors in the market. We have service people who are coming to our homes to perform certain services. For example, if we have purchased a refrigerator or, for example, a television, service people come. Of course, in case of companies, there will be existing customers, and we are also trying to capture the potential that exists as far as expansion of business is concerned. And we have sales happening in a particular territory, and these sales have been captured or measured in terms of lakhs. Now, this is the data view. This is all, remember that this is all hypothetical for the purpose of understanding we are using. So I'll go to analyze. Now in analyze, what we'll do is that we will go to, regression. And in regression, we will be implementing this or using this option, linear regression. Now in linear regression, this is the kind of window that will be opening. See, very quick, let me just blow it up so that it becomes more visible. So we have dependent appearing, we have independents appearing, and there are certain other options also which are appearing. For the time being, forget those other options. Look at the dependent and independent. Now, what is a dependent? We saw that sales in territory is the dependent. And what are the independent? These all are the independent variables. So we will highlight them and we will shift them to the independent. Now leave all other options like this. Don't do anything. Don't do anything to model fit, or suppose we can say that, suppose we can have descriptives, we can have R squared change. Suppose we want the software to do for us, and rest of them let us leave like that. Let us see what we have in options. On options we have probability or N3.05. Let us leave it like that, and let us give OK. Let us give OK. And OK, see what is happening. So we have descriptives here. It is giving us some mean scores. Of course, in certain cases, they're meaningless as far as number of competitors is concerned. 3.14, number of dealers, number of salespeople. It will depend upon the manner in which we have captured the data. Why I showed this to you? Because you may be using it in some other context. So this option already also exists, where descriptive statistics table can be generated by you. Then correlations table. This can be generated by you. You will find that this is, this represents the correlation between, say, sales in a territory. Of course, when you self-correlate, the value will be 1 here. And similarly, we can find out for others also. Now here, these tables are now important for us. If you look at this table, now it is telling us that what all variables we are playing around with. So it is telling us the names of the variables, and then a model summary is presented, because in case of regression, basically we are testing a model. And what was the model? The assumption was that sales are dependent on certain independent variables. And what are the independent variables? We have specified the independent variables in terms of the competitor activity, in terms of the service people, in terms of the sales potential, and so on. So these are the independent variables. So basically we are testing a model. The equation y is equal to a plus b1 x1 b2 x2 and so on that we considered, basically it is representing a model. So see, adjusted R square value that we are getting. Hello, is it clear? Hello. Hello.
Yes, sir.
Okay, there is some voice because I thought maybe there is some problem. So we have adjusted R square before us. So this value in adjusted R square, we are getting 0.9196. Now this value is close to 1. Let me caution you, this data is all imaginary, it is all hypothetical. So in real life settings, do not expect this kind of output. Do not expect that this value will be more than 0.2 or more than 0.3. If somebody claims that I got a 0.8, I got a 0.9, this data is definitely fudged. Because the kind of studies that we do, it is very difficult to get even a 0.2 or a 0.3 as far as this R square value is concerned, be it R square or be it adjusted R square. So this is all imaginary. That's why we are getting this. And what exactly this is representing? This is telling us that 96% of the variance in the dependent variable is explained by the independent variables. So it is telling us that yes, there is a very significant relationship between the variables on the right hand side, that is the independent variables that we are considering in the model, and the dependent variable which is on the left hand side, that was y for us. So it is telling us, I'm repeating, that 96% of the variance in the dependent variable is being explained. Now this is an abnormally high value. Let me caution you, in real life settings, it will not be appearing in this manner. Now look at the ANOVA. Again, see, we have an ANOVA, but in this ANOVA, interesting thing that you will note is that, see, the value that we are getting in under significance column, or the p value, is 0.000. So this means that it is significant. It is why? Because it is less than 0.05. So what basically it is telling us that this model is a satisfactory model, that yes, it is a working model. We can proceed further. It is okay. It is acceptable. That yes, it is trying to explain what we are trying to find out through this particular model. So then, and you note that the lower the significance value, the higher will be the F value. This is another interesting thing that we should note, that the lower is the F value, higher will be the significance value. And this would, if the significance value is high, that it is more than 0.05, of course, this means that the model is not converging, the model is not significant. Now let us look at the coefficients table. Now this coefficients table is interesting in the sense that it is giving us some interesting outputs here, which we need to analyze. Now look at constant value. The constant value is 0.3173. Now let me take you to the output. Is this output visible? Is this visible? Correlation regression PPT?
Yes, sir.
Okay.
The output is not. It's PPT correlation.
Yeah, PPT. I've shifted to
Yes.
PPT just now. See,
Yes.
in the output, see, it is 0.317. And just please again recall, we have for potential, we have 0.23. So output is this 0.317 is nothing but A that we had in the previous slide. See, if you recall, in the previous slide, we had, see, in the previous slide in this model, very quickly, sorry. In the previous slide, we were discussing, let me come down to that equation. Yes, look at this. We had A's intercept, we had B1, B2, B3, they were the coefficients, and X1, X2, X3, they were all the independent variables. So if you look at the last PPT here, what we note is that we are getting 0.317 instead of A, and we are getting 0.23 instead of B1, 0.82 instead of B2, we are getting 1.09 instead of B3, and so on. Now let me come back again to the SPSS output. Now look at this SPSS output. In this SPSS output, you will note, is it clear, or should I paste it on? Let me just take it to, yes, I'm just blowing it up so that it becomes more visible and more clear to all. Is it more visible now?
Yes, yes.
Okay. Yes, I hope. Now, if you look at this constant, see, this is what we are discussing. If you look at this constant, this is what we saw. This is nothing but A, the intercept that we were discussing. If you look at the potential, if you look at this, see, this is the B1, this is the B2, this is the B3, this is the B4, and so on. So you will find that how to find out that which is B1, B2, B3. For that, you have to look at how you have basically mentioned it in your model. So these are the coefficients which should be, and you have to take care that what is the symbol which is appearing, whether it's a minus or a plus, because plus will mean that it has a positive effect there. It will be contributing, and in case index of competitor activity, you note that it is negative. Just note here that this is negative. For those who it's not visible, it is negative. It is minus 1.893. So what it is telling us is that higher the competitor activity, it will be having a negative effect as far as your sales are concerned. Logically also it appears to be correct, that if more of competitors are there, more of competitor activity is there, the more aggressive your competitors are as far as your activity is concerned, your sales will be adversely affected. Similarly, but interesting finding which is appearing here is that number of salespeople, we are getting a minus coefficient here. Minus. So this means that more number of salespeople will definitely not help in improving your sales figures. So this is what we are finding, and rest of them, they are all positive. Now, if you look at the significance values vis-a-vis T values that are appearing here, I'm basically talking of these values. Let me just color it using a different color. So look at the significance values here. Now, in these significance values, what we note is that, see, what we note is there is this significance value, see, T in case of the sales potential, and in case of this, see, this value, these two values, let me just undo this and highlight on them, 0.016 and 0.031. So these two values, interestingly, they're less than 0.05. They're less than 0.05. And what it is telling us is that as far as this particular or this model is concerned, what we're getting is that the number of salespeople and the sales potential in a territory, it has significant bearing as far as the sales output is concerned or the dependent variable is concerned. So please mind you that if somebody asks that which are the variables which I should focus more on as far as this model is concerned, or if you want to suggest to your client, or if you want to, for example, in social science research, you want to decide that which are the variables with which you should be concerned with first. So you should be looking at these significance values. They can help us in finding out that which of the variables require more of attention from our side and which are playing a more important role as far as our model is concerned. So you will look, you will note that as far as the coefficients are concerned, they are also higher as far as these particular t-test values are concerned. In case of 0.016, this is 0.227. As far as 0.031 is concerned, we are getting a coefficient value of 1.091. So in fact, these standardized coefficients, what basically they're telling us is that for every full standard deviation of movement, we see one standard deviation of movement. This is basically telling us that for every one full standard deviation of movement, this is how this will be changing. So this means that this number of sales people will be having a significant bearing on the overall sales as far as that particular territory is concerned. Now let me come back to again this. So this is, remember that in this output that we discussed just now, we have the coefficients here. This B1. This is the first one, the constant was the A, and the rest of them were the coefficients for each of the variables that we had. So this is x1. Let me again come back to this. So this is beta B1, this is B2, this is B3, this is B4, this is B5, and the last one is B6. So and hello, am I still online? Is there some problem? Hello. So very quickly, am I audible? Please, am I audible?
Yes, sir. Yes, sir.
Okay. I thought maybe I'm offline again. So for those of you who could not follow, I'm just repeating it again, how we went about, doing this analysis using the data that we have with us. So I'll just show to you the correlation, this regression data that I had with me, and I'll go to analyze. After going to analysis, I go to regression. After regression, I select linear. In linear, let me reset it. And these are the variables which are appearing on the left-hand side. I know that sales in territory is the dependent variable. I know that these are the independent variables for me. I went to statistics. I instructed the software that, okay, give me our R squared output change that will be happening, and also the model fit and so on. Then what I did was that I simply gave okay, and this is the output that I got. So here again, let me remind you. Now let me just take this to, because I feel that it may be not very visible to some of you. So let me just quickly take this here. So this is the model summary that we are getting, and I'll just paste that other one also, because I know the table for some of you may be too small to be visible. So I'll just explain that very quickly here again. So see, this is the output table that we are getting. What I was sharing with you is that we look at this R squared value. This R squared value that we are getting is 0.96. In real life settings, do not expect this high values. You will be getting a 0.2, or you may be getting a 0.15 even. And if some researchers get a 0.2 or 0.3, they consider themselves very lucky. So what this is telling us is, this adjusted R square value, what it is telling us is that 96% of the variance in the dependent variable is being explained by the current independent variables that we have considered. Now, some of the researchers, what they do is that once they have tested, because this is a hit and try approach that we are following, so what they may do is that they may also try by removing some of the variables. They remove one of the variables, then they look at the adjusted R square value. They remove another variable, then they look at the R square value. And then they will present that model which gives them the best R square value. And this in a way is model testing also. What we can do, we can test the model by removing some of the independent variables. And how we can find out which of the variables we can remove, which of the independent variables, we can look at the output table that we have before us here. And by looking, for example, at the significance values vis-a-vis the T output that we are getting, we can decide that which of the variables are not contributing very much as far as the dependent variable is concerned. So we can refine the model, we can improve the model. If you don't want to use, for example, a higher statistical technique like structural equation modeling, so some of the researchers, they do some beautiful analysis using simple regression tools like this that we are discussing here. So this is the ANOVA output. If you recall, we discussed that this value that we got here was less than 0.05, and I was sharing with you that this this value is quite high, F value. So the lower the significance value here in this particular column, the P value, the higher will be the F value as far as ANOVA table is concerned. What this table basically tells us is that whether your model is satisfactory or significant model or not, whether it is converging or not. So if the significance value is more than 0.05, it is telling us that it is not converging. So this means that we may have to try by dropping some of the variables, or we may have to radically, think of some other ways of performing our analysis. So this is one way of carrying out your analysis or testing of the model. Now, because we are already 121, so let me quickly show to you factor analysis also, so that at least I'm able to cover the whatever I had planned beforehand. So I'll be for factor analysis, I'll be using another example because this may appear to be a bit too complex. So I'll go to factor analysis, and in factor analysis, I will demonstrate using this simple example. So we have some variables with us, and what are these variables? Look at this. What are these variables? Now, in factor analysis, what we are doing is basically we are trying to reduce the number of variables with which we are playing around. Is my variable view visible to all? Is my variable view visible to all?
Yes, sir.
Okay.
So Excel sheet is there.
Okay. So in factor analysis, what we are doing is, see right now before you on the screens, you have certain variables which I have named U2, W, SF, LMC, MV, power, and so on. Now, the description of these is given in the table. See, the first variable is connected to, I use a two-wheeler because it is affordable. Second is, it gives me a sense of freedom to own a two-wheeler. Low maintenance cost makes a two-wheeler economical. A two-wheeler is essentially a man's vehicle. I feel very powerful when I'm on a two-wheeler. Some of my friends who do not have their own vehicles are jealous of me. I feel good whenever I see an ad for a two-wheeler. My vehicle gives me a comfortable ride. I think two-wheelers are a safe way to travel, and 3 people should be legally allowed to travel on a two-wheeler. Now, these are some interesting variables that we have before us. Now, we want to find out that can we somehow minimize the number of variables? Can we reduce the data that we are playing around with? So because as this factor analysis is nothing but a data reduction tool. So let me show to you the data view. See, we have collected data pertaining to some kind of scale. So we have asked the respondents that whether they agree with this or disagree with this, and the respondents have given us the responses. So if you want to find out that what kind of profile is emerging as far as descriptives are concerned, frequency counts are concerned, so what we can do is that we can shift all of them to the variables window, and we can generate an output. So it is telling us that we have 20 valid responses, and the scale that we are using is a 1 to 5 scale. And in case of, it gives me a sense of pleasure, it's a 1 to 6 the respondent has given. So we are using basically a 1 to 7 scale, where the highest value in case of the first variable is 5, the highest value in case of second variable is 6, the highest value in case of third variable is 5, and so on. Now let us try to implement or see that what will factor analysis do. Now we go to again the data that we have with us. I am showing you the data view. This earlier one was the variable view. This is the data view. I go to analyze. I go to dimension reduction, because let me repeat, factor analysis is a data reduction tool. So let us go to dimension reduction option, which appears under analyze. Go to factor analysis. In factor analysis, these are the options that will be, this is the window that will open up. So let me just make this window bigger so that it becomes more visible to you. Now this is the window. On the left hand side, we have the variables. We can make them short. See this is the short version. I can shift all of them, and I have to shift all of them to the variable window. Then I'll go to descriptives. In descriptives, I will select KMO. I will select and let us leave it like that. Let us not do anything else. Let us go to extraction method. In extraction method, see, there are so many types of methods: principal component, unweighted least squares, and so on. Leave it to principal components. Let us generate discrete plot also, and let us leave rest of the things like that. Let us go to rotation. In rotation, though I would have liked to discuss direct oblimin and so on, but let us select Varimax because this is the most commonly used rotation method in social sciences. So I'll select Varimax, and let us go to options. Let me show you the options which are appearing. I'll activate one of the options later on. Right now I'm leaving it. I'll show to you what's the advantage of activating these options, and I give OK. Now the moment I give OK, I get an output of this type. See, I get an output of this type. So it is giving me in the first table the KMO measure. In the second, it's giving me Bartlett's test of sphericity. Now, because we are not going into how KMO is calculated or how BTS is calculated or Bartlett's test of sphericity is calculated, let us focus more on interpretation part. See, as far as KMO measure is concerned, you find the value of 0.622. See, this is the value that we're getting, 0.622. If I blow it up and paste it in the Word file, let me show to you what we're getting. So this is the table that we're getting. Sorry. Copy special. Let me paste it. Let me paste it as an image. Just a moment, because that will make it bigger for you. I'm pasting it as an image. I hope my Word file is visible.
Yes, sir. Yes, sir.
Okay. So KMO values, what we note is that KMO is 0.622, and Bartlett's test of sphericity, we are getting a significance value of 0.000. Now, this, remember that KMO measure, this value should be more than 0.5 ideally. Some people consider even 0.4, but I'll suggest that let us be conservative. This value should be more than 0.5. As far as Bartlett's test of sphericity is concerned, if this value is more than 0.05, there is a problem. There is a problem. This means that we should not be proceeding further. Now, this means that sample is adequate. Right now, for us, the sample is adequate. We can proceed further. Again, it's all imaginary. Please keep this fact in mind. So now look at the commonalities table here that we have before us. Now, higher the commonality value, the better it is. And some of the researchers, they treat that 0.4 is okay. Some of them say 0.5 is okay, but really consider 0.5 as being okay. So you will find that some of the values are quite high. Say some of them are 0.945, some of them are 0.7. Again, let me just copy it, because what I feel is that there may be some issues. Let me just copy it and just blow it up in the Word file so that you are able to note it very clearly. So see, we have, just a moment, let me just portrait. I'll just make it bigger for you so that it becomes clearer to you. I hope it's clear. I hope it's clear.
Yes, sir. Yes.
Okay. So,
yes,
so
sir,
here
yes.
what we have is, see, the extraction values in case of the first variable that we had is 0.721, second is 0.522, third is 0.806, fourth is 0.945, and see the last value that we're getting is 0.468, which is lower than what we consider to be satisfactory. Though some of them may say that if you round it up, it becomes 0.5, but let us, for the purpose of understanding, consider that this value is a lower value, and the next lowest value is 0.522 that we are having here. Now, another thing that we have to keep in mind is that when we are interpreting this, we also look at the total variance explained table. Now, in total variance explained table, what we are noting is that 3 factors are emerging out of this. 3 factors are emerging, and roughly 80% of the variance is being captured or being explained by these 3 factors, which is a quite satisfactory value that we are getting. Again, let me caution you, in real life settings, you will not be getting these kind of values in the first go. You may have to go in for a lot of refinement or dropping of some of the variables based upon the loadings that we'll be seeing in the subsequent tables. So you may not be initially getting this kind of high values. Now, a scree plot, generally we consider eigenvalue of 1. So all the values which are higher than eigenvalue of 1, see left hand side eigenvalue. See, we have 3 factors which are appearing. This factor 1, factor 2, and factor 3. Rest of them, they comprise the debris, or they are junk for us. They are not of much help to us in explaining what we are trying to find out. Now look at the first table, we are getting a component matrix table, and the second table is the rotated component matrix table. This is the table which is important for us. Now what we find is that in this rotated component matrix table, so much of values are appearing before us. So it at times becomes difficult for us to interpret. So now here comes the role of, what I was sharing with you, one of the options which I did not purposely click. I'll go to scores, and I will instruct the software, I'll go to options, and I will instruct the software to suppress certain types of values. So let me instruct the software that you suppress all the values which are less than 0.5 for the purpose of understanding. I go to continue. Rest of the things are the same that we considered earlier. Now in this next output, because all the rest of the things are the same, let us move directly to the component matrix. Now if you compare this component matrix to the previous component matrix that we had here, you will find that this was a bit cluttered. It had so many values in it. It may have become difficult for the researcher to interpret and to find out that what kind of loadings are emerging. Now this gives us a more clean rotated component matrix. Now what we can make out from here. Now one more thing. Okay, one more thing that is missing here. Now if you go to options, factor analysis, the same options, you can also instruct the software to sort it by size. Let us see what happens here. I give OK. Now again, if I look at sorted by size, you will find that now it has sorted it by size. Am I audible? Am I audible? Hello?
Audible.
Okay.
Sir,
fine.
you are audible, sir, but system will, the platform will log us off, after 15 minutes. So we have
fine. Let me just quickly wind this up. So this is the rotated component matrix table that we have before us, and I instructed the software to arrange them in descending order. So what you find is that the first variable that is emerging is comprising of how many? I feel good whenever I see the ad for my two-wheeler. My two-wheeler is essentially a man's vehicle. So these statements, which are on the left-hand side, the 7th statement, the 4th statement, the 5th statement, the 6th statement, they're loading on factor 1. This is how we can interpret. They're loading on factor 1. Now, another set of statements, 9th statement, I think the two-wheelers are safe way to travel. Up to the 2nd statement, the 9th, the 8th, and the 2nd one, they're loading on the component 2, that is factor 2. And another 3rd one is also loading on this component 2. Now, as far as the 3rd component or factor is concerned, we find that the 1st statement, the 3rd statement, and the 10th statement, they are loading here. Now, the first thing that we need to do is see the difference between the 3rd statement. Low maintenance cost makes two-wheelers economical. In fact, it is giving me cross loadings in a way. So, because I want to explain to you that how to take care of cross loadings. If we are getting a picture of this type, when the values that we're getting in case of particular variable, or it is getting loaded in case of two constructs which are emerging, then something needs to be done by us. So what I'll be doing is that I'll be removing the third variable for the purpose of demonstration. Let me remove it. So what is the 3rd variable? Let me just show the 3rd variable. I think is the 3rd variable is this variable information. Yes, this is the 3rd variable, low maintenance cost. So I'll just remove this 3rd variable and again run the factor analysis, leaving rest of the things the same. So see here what happens. Here what happens is that the output value has improved. The total variance extracted has improved. And what I note is that the rotated component matrix, what I was finding earlier, that cross loadings are gone, but I have removed one of them. So what has happened is that the last variable, the factor which has emerged, now only 2 variables are loading on it. Ideally, we should be having at least 3 loading on one, because otherwise it tends to create problems later on. But sometimes if you feel that they are essential, because theory tells you that they're very essential, so you may decide not to drop them, because remember that whatever statistical tools we are discussing, they do not exist in vacuum. These statistical tools, or whatever we are supposed to interpret, we are supposed to interpret that those outputs, or whatever outputs we are getting using the softwares, in the context of our research design, in the context of theory. So you have to keep this also in mind, and not simply keep refining, or not simply keep dropping the variables depending upon the statistical output that we are getting. But of course, what has happened is that the values have improved. Why? Because we look at these values, we look at the commonalities values, and here what has happened is that see all the values, they have improved. Now the values are more than 0.5. None of the values is less than 0.5. So in a way, what I'm demonstrating to you is also part of refinement of, suppose this was a scale, so this is refinement of the scale, or this is also, you can say in a way, a procedure through which, an iterative procedure through which we can drop some of the variables which are non-contributory variables, and collapse them into lesser number of factors. And see, the software will not be telling us what is the name that is to be given to these 3 factors which are emerging. We as researchers will be naming these factors depending upon the various items or the variables which are loading on these factors. Based upon that, some name can be given by us as researchers to these factors. So each of the three factors which are emerging can be given a name based upon our understanding of the contributory variables to each of these factors. So how we can say that this particular procedure is a data reduction tool? See, what it has done is that earlier we were having a certain number of variables with us. So what it is helping us do, what factor analysis is helping us do is helping us collapse them into just three factors. So what we can do is that we can now play around with these three factors, and each of the factors is emerging because how we have decided that, okay, and how we'll be naming them, because see, 7, 4, 5 and 6, they are loading on factor 1. So we will say that factor 1, these are loading on factor 1, and factor 1 is basically representing these 4 variables that we have with us. So towards the end, what we can do is that we can now compare the responses of, in terms of genders or in terms of occupational groups, in terms of the factors that will be emerging out of this operation, out of this entire exercise of going in for factor analysis, rather than comparing them in terms of the individual variables. Now with this, I hope that I have covered nearly all. I wanted to cover t-test, I wanted to cover ANOVA, I wanted to cover factor analysis, I wanted to cover regression, though it is, I know that it is too much of statistics, but still I thought that I should be introducing you to this idea. And also, as far as testing of factor this hypothesis is concerned, if you recall, we have discussed that part also. But very quickly, let me just summarize what we discussed as far as hypothesis testing is concerned. If you recall, we discussed the concept of in hypothesis testing. We discussed that how to interpret the hypothesis. We have to be clear about the concept of confidence level. Confidence level plus alpha should give us 1. It gives us 1. So if alpha equals 0.005, then the confidence level is 0.95. If you increase the alpha, you both increase the probability of incorrectly rejecting the null hypothesis, and also you decrease your confidence level. Now, if p-value is low, null must go. This is how you can remember. If p-value is low, null must go. So null must go. P-value is low. If p-value is high, null, the alternate hypothesis is holding true in a way. So if p-value is less than alpha, the risk that then you are rejecting the null hypothesis. And if, for example, it is greater, if p-value is low, remember this one easy way of remembering. Alternatively, if p-value is greater than alpha, then we fail to reject the null hypothesis. Or if we put it together, if p-value is high, null will fly. This is one of the researchers who has given this. If p-value is low, null must go. If p-value is high, the null must fly. The null must go. So so this is in short what we have discussed. So of course, I think by now, I hope that I have been able to share with you the various tests that we can perform. I hope I've been able to share with you the logic that goes behind the use of various tests. So let me repeat, if you want to compare 2 variables or 2 levels, we go for the t-test. If you want to compare more than 2 groups, we go for ANOVA. If you want to compare 2 groups and you're using ANOVA, I will always advise that do activate the post-hoc test. If you want to find out, for example, the effect of certain number of variables on a certain variable, we go for testing of a model generally. Beginners can go for regression analysis, the way I've explained or shared with you, and it can give you a beautiful picture or help you in finding out which of the variables are contributing significantly as far as that model is concerned. For testing the model, we look at the ANOVA output table. If the ANOVA output table, the significance value that we're getting is less than 0.05, it basically conveys to us that the model is a satisfactory model, it is converging, but it doesn't mean that it is the best model. Let me caution you, it doesn't mean that it's the best model. If the R-squared value that we're getting is, say, something like 0.5, 0.6, it is telling us that 56%, suppose it is 0.56, it is telling us that 56% of the variance is being explained by the variables of the variance in the dependent variable is being explained by the independent variables that we have considered in the model. Thank you very much. I'm open to questions, please.
Sir, questions have been sent to you.
Okay, so I'm sorry, because I got so involved, engrossed in this, I was not looking at my mobile phone. So let me just look at the, okay. very, let me just, yes, sorry. I think I have already covered this dependent variable example. Somebody was asking, I have covered this dependent variable example. Please share again suggested books. Okay, I'll share that. Let me just, I think I shared that in descriptive. So let me.
Sir, we will take, please take a couple of questions because we'll be logged out by the system.
This is the textbook. Somebody was asking. This is one of the questions. In fact, it is essential to take hypothesis in every research. No, certain researches we go for propositions. For example, it is not necessary to use the terminology always of hypothesis. Researches can be done otherwise also. Now, what is the use of hypothesis in conducting qualitative research?
Sir, we will request the students to write because we will be automatically logged out by the platform. So I thank you, sir, and I request Shipraji to please propose vote of thanks before we are logged out by the system.
I hope you see. I was looking at the questions which they have posted. In most of the questions, I think I've covered in one way or the other.
Okay. Shipraji, over to you.
Yes, ma'am. So on behalf of Dr. B.R. Ambedkar Central Library, JNU, I extend a very hearty vote of thanks to Honorable VC Sir, respected Rector Sir, and Registrar Sir for their continuous support and encouragement to organize such kind of virtual workshops. I would like to express my sincere thanks to the speakers, especially to Professor Naved Khan Sir. Sir, it is always great to listen to you. Thank you for being here on this platform. And at the same time, Manorma ma'am and the representative from Drillbit Software. And I also wish to express my gratitude to all the participants because without them, it would not have been possible. And Drillbit team for their generous support, my colleagues from Central Library and CIS team. Thank you so much. Ma'am, over to you, ma'am.
Thank you to all of us and best wishes to all of us. Thank you, and now we log off.
Thank you, sir. Hello. Thank you, ma'am.
Sorry, I again got logged off. I could not hear the last part. I wish to thank all of you. I wish to thank Manora ma'am. I wish to thank the rector. I wish to thank the registrar for giving me this opportunity to interact with the participants. And I wish to thank the participants for being patient listeners. Thank you very much.